Welcome to 2025. So this year, I really want to bring back some more serious educational content to this channel. And so today, we're starting something special. Now, this idea began somewhat recently in my latest code review video. I went back and took a look at what was pretty much the first code that I ever wrote for an actual real sort of project. It was this multiplayer on one keyboard game called Squared, where you basically just move around and try and catch each other. Very fun. And so going all the way back to the beginning and seeing that first project of mine really made me want to do kind of the same thing with this channel. And so what I've decided to do is remake that game in C++, make it real multiplayer over a network in 3D using Vulkan ray tracing. Is that enough? Basically, call it a New Year's resolution, if you will. I want to go back and fulfill all of the promises I've been making as to things that I need to finish or talk about in the first place, such as application architecture, Vulkan tutorials that people have been asking me to make, and of course, the ray tracing series and GPU ray tracing. So why not combine all of that into one big fun project and make this game kind of from scratch in C++ and show every single line of code in this sort of live tutorial format, as I'm calling it. Now, let me address a couple issues with this concept. First and foremost, big, huge projects and series like these don't generally tend to fit the YouTube platform very well. Of course, you can make long videos on YouTube, but viewership tends to fall off, and generally they're not as good for the creator when compared to something like a paid educational course. The second issue is to make this more YouTube friendly, it's common to do only a little bit of work in each episode of this series, making sure that the video title matches the concept that's being discussed, which theoretically gives you more consistent and frequent uploads because there's just more videos to make, but in my experience leads to a project that can last years and make very, very little progress with each video. So let's address these two issues. The first one we're kind of just going to ignore. I hope that the other videos on my channel will be successful enough to sort of drive this project. And of course, your support on patreon.com/thecherno is much appreciated. Now, as for the second issue, I want to release big, huge videos that match the big, huge nature of this project in which substantial progress is actually made. So I basically just want to make long videos in which we achieve a lot and we get a lot of work done, which you may have picked up on if you've noticed this video's length. So it's a new year, we're going to give this idea a go. That way, hopefully, once a video is released, you don't have to hope that the creator, me, keeps uploading and gives you enough content to at least finish the part that you're working on. Instead, you've got the full video of a particular concept, I guess, like this one here today, and you can just progress at your own pace. So hopefully that's a good idea. I think if I was a viewer of this video, I would probably prefer this. So please let me know if you like this or not. Leave a comment below. And of course, don't forget to like the video if you like it. Feedback is very important. Okay, so now let's talk about this project. So the game that we're remaking, Squared, I'm not going to talk about it in this video. I encourage you to take a look at the previous video, which was the code review, because me and my wife actually played this game for a solid 5 minutes. So if you want to see what the game is like, go to that video. Second of all, the tech stack behind this project, meaning what technologies we're going to be using. Latest version of C++, I'm going to be using MSVC and Visual Studio. However, this will compile on all platforms and compilers. In fact, later in this video, we will be compiling the server on Linux. Yes, that's right. In this video. Now, when it came to choosing a library to be the basis of this, I thought about this for a long time, and initially Raylib was what I thought I would use. However, I realized that it really wouldn't be a very good fit because Vulkan ray tracing, it's a 3D game, so we'll probably need a 3D physics engine. It just didn't really make much sense to use something like Raylib. Hazel, of course, doesn't fit because Hazel is a game engine, and this project is about writing something more or less from scratch in C++. So I settled on Walnut, an application framework that I made a couple years ago. It's completely public and open source on GitHub. I'll have a link to it in the description below. The reason why I chose Walnut is because it's really lightweight. It's kind of like a collection of other libraries like glfw, glm, dim GUI, kind of set up in a very, very basic application framework. Honestly, I encourage you to take a look at the source code and you'll see what I mean. It's so bare bones that we are almost starting from scratch, but it's just a little bit of a nudge that will make some things easier. And in fact, for this project, we'll actually be expanding Walnut quite a bit because it is quite bare bones and we'll want it to do more for us. But yeah, that's one of the rules for this project as well, is that everything we use, every third-party piece of code or library has to be open source. So that way anyone following along with this project can see all of the code. Now, speaking of code, the code for this project will be free and open source on GitHub. I'll leave a link to it in the description below. It'll be in a repository called Cubed, because Cubed is like the 3D version of Squared. Now, I did briefly consider making the code only accessible by patrons who support this series on Patreon. However, I did want this educational content to be as accessible as possible, even though you shouldn't really need the source code if you're trying to learn, because following along with the series, making your own thing is going to teach you a lot more than just copying the code from GitHub. But nevertheless, hopefully that additional resource will be useful to you as well. And of course, if you want to support this project, then patreon.com/thecherno. Much appreciated. In fact, if you do become a Patreon supporter, you can get access to something a little bit more substantial, like Hazel. And finally, let's talk about this video. So this video has chapters in the description below, which means that on the timeline of this video, you will see all of these chapters. I encourage you to take a look at them so you can see what is in each video. So in this video, predictably, we'll be starting at the beginning and creating our project. And then in this video, we'll be going all the way to creating a server that's running on a hosting a VPS on Linux, to which multiple clients can connect to and can like move around and like see each other, like a basic multiplayer server client architecture game setup. So yes, getting a lot of work done today. So anyway, without further ado, let's begin. So we literally are going to be beginning at the very beginning. And I hope the beginners will appreciate that we're beginning at the beginning. So over here we have GitHub. This is my GitHub profile, I guess. I'm going to create a new repository. And I'm also going to take a look at this Walnut repository from Studio Cherno, which is of course what we're going to be using for this. So Walnut has a branch here called dev. I updated this like an hour ago just in preparation for this, just fixed a few things and made sure it was roughly working. There is actually a Walnut app template that you can use. So if you go use this template, you can create a new repository from this template. And this basically just has like some starter code, I guess. It uses Walnut as an external submodule rather than actually relying on, say, the example project from within this. We're not going to use this app template. I'm going to show you how to really set this up from scratch. Also, this app template points to the master branch, not the dev branch. That's another reason why I just didn't want to dive in and start changing everything here. So let's create a new repository here from scratch. So I'm going to call this Cubed because the original game, of course, was called Squared, but this is 3D. So we're going to call it Cubed. Description, we'll just leave blank. Public. I'm going to add a README file, and I guess we can add like a C++ git ignore. We're probably going to modify this. I don't know if this knows we're going to use Visual Studio, for example, so we might want to ignore certain files from ever being committed into our repository. And then for the license, look, I don't really care. We can just pick a MIT license because that's pretty popular. And it's also going to set main as the default branch. So master is kind of a thing of the past. Main is the preferred name to use these days. I don't really care, so we're going to stick with main. Okay, let's create the repository. So once we have the repository created, let's clone this onto our computer so we have it locally. So I'm going to go ahead and open this projects folder I have. Control L gets you this path, and I'm just going to type in CMD, hit enter, and then we just have a terminal. Just super easy way to get a terminal up. So for this to work, you need to have Git installed. I'll leave a link in the description below. I don't know how basic I want to get, obviously, with this little series here. Just install Git if you don't already. So let's type in git clone. We don't need to do recursive because there's no submodules yet here. And we're just going to type in cubed, like our paste in our path here, and hit enter. This should take like 2 seconds. Okay, it's done. So over here we have the code that has been created for us by GitHub checked out locally. So well done if you got this far. And that's the end of this video. I hope you guys enjoyed. I'm just kidding. We're just getting started. As I mentioned, I'm going to try and actually like get a lot of work done in each sort of episode of this. I don't even want to call it an episode of a series because I don't want this to be a series. We're just going to get a lot of work done in this video. Okay, so from here, the first thing that I want to do is I want to get to Walnut and I want to actually add this as a submodule. So this entire Walnut repository, I want this to be a submodule. So to do that, let's just grab this path. It doesn't matter about the dev branch. We'll indicate that we want that later. Let's first of all get into that cubed repository that we just created. We can just do a git status to make sure this is in fact a repository and that it's set up correctly. And then we can just do git submodule add. Now, I honestly always forget this, so you can just type in --help and it will tell you what to do. Again, being super real here in this live tutorial. So we want to do git submodule add, and then you can see we can indicate a branch. So I can indicate my dev branch. So let's do git submodule add, and then what was it? -b dev. And then we've got a repository basically and a path that we need. So the repository is going to be the URL that we have here. And then the path that we want here. So, okay, let's think about this. So we're going to have our main repository like over here, meaning like the actual cubed repository will just be in this root directory, obviously. So Walnut, I mean, Walnut's a pretty big deal. It runs everything. So I think we can probably just have it in Walnut. Like I'm not going to bother putting it into like a third party or a vendor folder. I think it's very, very core to everything we're using. So I'll probably just have the app outside in this directory and then Walnut as a submodule. This is very similar, obviously, to what we had with the Walnut app template, where we just have this repository here. The actual app is here, yeah, but then the Walnut submodule is also in this kind of root directory, but it's a submodule and it's pointing to another repository. So let's go ahead and just type in Walnut. I think it would have done that anyway because the name is Walnut. And again, we are adding the dev branch specifically here as a submodule. Let's hit enter and hopefully this will work out. So git submodules in general, if you don't know what they are, I recommend you do some reading. I might leave a link below which explains what it is, but basically it's just a way to reference another repository from your repository. So instead of us copying and pasting like all of this stuff here that's inside Walnut into this repository, which we could have done technically, we're just pointing to a different repository when we require those certain files. And of course, you can change that submodule to point to any commit, any branch of any repository you want. So in the future, if we want to update that submodule, we can do that without having to like recopy all the files and keep track of them ourselves. That's the other big thing here. We obviously want to make managing our repository as simple as possible. And if we have like so many other files that are external that we have to track and like update changes for and commit changes to, all of that stuff within our main repository just makes everything really noisy. Instead, this kind of lets us focus just on the game, I guess, that we're building and not the third-party stuff, because they'll be isolated into these submodules and we'll have to actually go into the submodule if we want to modify things manually or pull or update the submodules like that. Okay, so one thing I've noticed here is this was suspiciously fast adding this, so it must not have recursively checked everything out. I don't know if we have to do like a git submodule update, maybe with some kind of, oh yeah, recursive. So we'll probably have to do this. So let's actually just try that. So git submodule update and then recursive. That might just download everything we need. And the reason why is because, yeah, that didn't work. We might have to go into, how do we indicate which one we want? Okay, so I always forget this whole init situation, but basically there's nothing to update because they haven't been initialized yet. So what we want to do is git submodule update, recursive, yes, but we also need to do init, which is over here. Basically, the idea is that inside our repository, we have Walnut, and then we have vendor, which has all of these other dependencies that Walnut itself has, and they're also all submodules. So for example, GLFW is a submodule, but if we go into it, it's empty because we haven't actually recursively initialized and pulled all of those submodules within our Walnut submodule. So to do that, we need to do git submodule update, pass in init to initialize first those submodules that haven't even been pulled at all. And then also we want to do that recursively, meaning that we want to drill down all the way and initialize and pull all of those submodules. Okay, so there we go. We're getting some stuff. Now it's going to clone all of our submodules. Okay, cool. So we've checked out all of our submodules. Everything seems to have worked. Now, as I mentioned, the end goal of this video is to get this actually running on a real server, on a real VPS on the internet. So let's go ahead and make sure that's all set up and ready for us to use. Now for this specifically, we're going to need like a pretty decent VPS. We need to have full root access so we can do whatever we need on our server. We need it to perform well. We need some decent hardware. And of course, we want all of this to be reasonably priced and great value. And for that, there's really only one thing that comes to mind, and that is Hostinger, the sponsor of this video. So Hostinger by far are my favorite web host. Whether you just need a simple website or a fully controllable, powerful VPS, like in our case, they've got you covered. And they've currently got a giant New Year's resolution sale. For this project specifically, I'd probably recommend like a KVM2 or a KVM4 since we do want a little bit of power. But the great thing with using Hostinger is you can easily scale this to fit your needs. So if you get one and it's just not fast enough, you can always upgrade. Now, of course, these VPSs are going to come with full root access, which we need, but then they're also using AMD's EPYC processors and NVMe SSDs. So they perform really well. Head on over to hostinger.com/Cherno, pick a plan, and then when you're checking out, make sure that you use coupon code Cherno to get an even bigger discount. Once you've got your server, it's super easy to set up. The first thing you need to do is just pick a location for your server. I'd probably pick the one that's closest to you, which is easy because they actually measure your latency and pick the best one for you. Then you need to pick an operating system for your server. I'm just going to pick Ubuntu 24. That's the same as the Linux PC I have here in the office. And then finally just create a root password and you are done. It'll take like 5 minutes or so just to set up and it's ready to use. Then you'll be greeted with this dashboard, which I really like. I think it's really clean and it has all the features you would expect. And Hostinger also has a whole bunch of really well-written documentation if you need help with managing your server. From here, we can of course just SSH into our server and do anything that we need. So if you need a server or any kind of web hosting, head on over to hostinger.com/Cherno. And of course, don't forget to use coupon code Cherno for an even bigger discount at checkout. Huge thank you to Hostinger for sponsoring this video and for providing us with a server to use for this project. So let's go back into the root of our repository here. And I don't really need to or want to initialize this completely from scratch. So instead, if we look at Walnut, there's actually a Walnut app that already exists here. And there's a script that will build an example project for Walnut. It's just that we don't really need to use that from within Walnut, and we don't want to because we want to keep this repository, we want to keep the submodule intact. If I open up our main repository here, cubed, inside Fork, Fork is a really, really good Git client that I highly recommend. I'll have a link to it in the description below. You can see that all we've added so far, well, we've modified Git modules and we've added Walnut as a submodule. And if we go over here into submodules, you can see that we have Walnut, which we can double click on, and then it will open a new tab. And you can see this is like the entire kind of isolated Walnut repository. So hopefully you can see that since this is in fact like a separate repository, basically, we can pull the latest code if we need to, we can switch branches, we can do all of that stuff. And this just sort of points to it. So obviously this means that we don't want to go into here, into Walnut and start modifying things at all. We just want to reference it and hopefully we can refrain from actually modifying it. Since if we want to modify it, we won't be able to push back to the server unless we have permission. And so that's generally where forking will come in. You can just take anyone's public GitHub repository, fork it, and then effectively make your own changes to your own fork, to your own branch, whatever, and then have that itself be as a submodule. We've done that with several other dependencies that we have just because we might need to fix bugs or modify some code to suit our needs better. But I'm going to try not to do that with Walnut. Obviously, I have permission to push to Walnut, so it's a little bit different, but still, I don't want to obviously modify the Walnut repository, just our code over here. So what I'm going to do is I'm just going to copy everything I want from here. So let's grab Walnut app. We're going to copy it out here, except I'm going to call it cubed. So this is going to be our actual like cubed project, which uses Walnut. Inside here, let me just rename this to source because that's what I tend to do these days. Walnut app, I'll just call this cubed app. And then we have build Walnut app, which I might just call build cubed. And this is the Premake build script that we can double click on and have a look at. So the project name, let's change this to cubed app. We'll keep it as a console app for now, C++20, which is good. This is all stuff that I'm guessing we're going to need. Now you can see that this actually goes back a directory and into Walnut source. That's not exactly what we want here because it assumes that just because we, of course, were within Walnut, or in fact within Walnut app, so we go back a directory and then into Walnut or vendor. But from cubed, we still have to go back a directory, but then go into Walnut. There are a few different ways we could do this with Premake. I'm going to just keep this simple. This is effectively just all Lua code, so you can literally program anything you can imagine to sort out your paths, like entire functions that might do, you know, call like operating system calls even to determine which directory they're in. Lots of stuff, very flexible. One of the great things about Premake, but I'm going to try and keep this obviously as simple as possible. So we are simply going to go back a directory and then into Walnut. So into that like repository basically, and then either into vendor or into Walnut itself to include all of these things. Now these include directories that are going to point to, I guess, variables that are defined somewhere else. So build Walnut example project and build Walnut external are two files that might be of interest to us. So you can see that this, for example, sets include directories to certain things. So we need to make sure that that's what we want. And then it's going to include Walnut and build Walnut. And really the purpose of this, I guess, is just for us to be able to include Walnut externally. So this is probably what Walnut app template, I imagine, would use. We could have also, I guess we maybe should have just done this. Walnut app template actually already has a setup that I think works similarly to what we wanted. And it's got its own Premake, which you can see will include Walnut external. So let's actually grab this. And then over here in the root of this directory, I'm going to we'll just call this premake5.lua. For now, at least, we'll paste in what we just copied. We can get rid of that. I'll call this cubed. Debug release and dist configurations. The start project will have set to cubed as well. Output directory is where our binaries get output to. You can see that we're just basically making like this path. We're making this directory from the current build configuration, so debug, release, or dist, the system that we're on, so like Windows, and then like architecture such as x64. So that's just like a little directory that we make for that specific configuration, the build configuration and platform, and that's where we'll actually build our binaries to. Then we'll include Walnut, Walnut external, which looks good, and of course, instead of Walnut app, we'll include cubed, which is this. And in fact, we called it build cubed.lua. I don't know if that's necessary. So the thing is, as I mentioned, the very first thing we're going to be tackling in this entire project is networking, because it's a multiplayer game and I really want to start from the beginning with that client and server architecture. So because of that, I don't want to, I guess I want to be able to build headless and build the server, or specifically build the server headless, basically from the beginning. So let's actually change around a few things. So let me call this cubed client, and then we'll call this cubed server. So we've got two different directories. I've just copied and pasted them. And with the server specifically, I want to have build cubed server, but then I want to copy and paste this and have build cubed server headless. Now, Walnut does actually have a headless configuration, which is great. So you can see there's build Walnut headless external, which is what we need to run. So we will verify in this video if all of that works, because I want to go as far as actually deploying all of this onto the server in this video and making sure that we have that server client communication already working. So build cubed server and server headless. For now, we can just do the build cubed server headless. This is our actual app, so we'll just need to make sure that we strip everything. Another good point of reference, by the way, is probably going to be Walnut chat. So I do have a repository called Walnut chat, which is, you can see, from Walnut app template. And this has this app server, app common, app client, because this was like a little chat application I made using Walnut like a couple of years ago, last year. I'll have that video linked up there if you want to check it out. But this is also going to be like a really nice, I think, point of reference for us. In fact, I might just steal most of the code from here just to speed things up a little bit. So we have build headless and we have build.lua. And of course the scripts, I think we'll set it up on Windows, and setup.sh might calls build headless over here with Gmake 2 on Linux and using the Linux binary for Premake, and Clang is the compiler. So that's great. We probably need like most of this, I think. And then app client and app server, you can see that this is basically our cubed server. This is our cubed client. We might actually need some common functionality. In fact, this is looking so good. I think I might pivot and just steal most of this. I don't actually want to clone this whole repository and steal stuff from it that way, just because I don't actually want all of this, but I think the whole build system for this and how that is architected, I think I basically want all of that. Okay, so I do actually have Walnut chat. I did end up cloning it, and I'm just gonna probably copy these build scripts and put them over here. So we did have, we did start making Premake 5.lua, which I think just defined the workspace and some other things. So let's actually get rid of that. I'm going to paste in build headless and build.lua. So these we're going to modify now. Let's get rid of this comment here. So this, instead of Walnut chat, obviously we'll call this just cubed, I guess, and then we can have cubed headless over here. The start project will probably just be cubed client. That's the thing, like, do I want to have two different workspaces? Probably, yeah, two different workspaces for the server and the client. So we might actually call this cubed client and cubed server headless. I don't know, the other thing that's probably worth considering is whether or not at this point we want to have a non-headless server at all. I'm going to probably say no. So we can just say that, okay, let's just have a server, let's just have client, and the server will just be headless, especially because this is such a simple project that I don't want to get too crazy here with complexity. So yeah, we can just say that the server is always headless. So we'll have that headless defined. We'll include app common, headless, and app server headless. Now, the thing is, this is obviously in this app common and app server directory. App server is fine. We can probably call this cubed server and then cubed client. We'll get rid of this completely. So we could include the server app in this solution. The thing is, it's not headless though, as in this client situation isn't headless, which means that Walnut wouldn't be headless either. So you can see here it's the headless Walnut, here it's not. So therefore I'm probably not going to do that. We'll just keep them completely separate. We'll have two different workspaces, two different solutions, one for the client, one for the server. App common, I'll just rename to cubed common, and then we'll have build cubed common, build cubed client. I'll just rename app to cubed basically. And then I can have, I think I'll leave headless on these build scripts as well. So it looks like we have to have a headless version of common and a non-headless version of common. That's interesting. I wonder why. Because common is, I'm imagining, is just like some data structures or like some structs, that define layout of types that are communicated from client to server. So I'm not 100% sure why that has to be headless, why there has to be a specific headless variant, but I guess we'll see. Okay, that looks pretty good. Let's go over here. Now, cubed client, cubed server, they're going to have things inside them as well. I'll just verify how similar this is to Walnut chat. So here's the build app client. Oh yeah, we did rename our directory to source, didn't we? So let's do that. We're also including app common source. So I guess we should probably do that. We'll say cubed common source. Ah yes, Walnut networking. That's important to include that we didn't have that because I guess the Walnut app template is from the master branch, which doesn't even have the Walnut networking submodule. So therefore it didn't have the include. So let's include that. Links. So yeah, we'll link app common and Walnut. Interestingly, this didn't link Walnut. I'm guessing because app common itself links it and maybe something to do with Linux. I don't know. I think app common will actually link Walnut itself. So therefore that should propagate. But anyway, we'll include both of them here for now. I don't know what this YAML CPP static define is. We'll ignore that for now. Looks like we do need some post build commands to copy these into the right directory. Yeah, that will be needed. So we'll just copy that into here. So all that's doing is just copying our game networking sockets DLLs that we need into the bin directory that we've just built to because they need to be there next to our executable. And that's not really going to be required on Linux because we can just set like our LD library path or whatever to wherever we want and just have them in either a common directory or alongside as well in some kind of external directory. I don't know. We'll talk about that when we get to actually deploying and running this on Linux. Okay, so for the server, I guess app common and app common headless, we can probably grab this from Walnut chat and just put this into cubed common, which again, we're not really going to have anything in here just yet, but we are going to need that, I think, going forward. So that's why I want to just start with that already here. So app common we'll call cubed common. And yeah, I want to, oh, right. Okay. So I think there's a headless version because for whatever reason, we decided to actually have Walnut here. And you can see that, for example, the non-headless version has IMGUI and GLFW, but this one doesn't. So it does actually have the full kind of Walnut functionality within here if we want it. So it's obviously optional, but I guess we can keep that. And so we've got Walnut and Walnut networking in the non-headless version and Walnut headless and Walnut networking in the headless version, which is great. And everything else I'm pretty much happy to keep. I'll just call this cubed common headless. So inside Walnut chat, you can see that inside app common, we did have a couple things here. And namely like this server packet, and I think we had, this is just packet type to string, but basically this was just like an enum class that was like, hey, here's a protocol for server client communication so that we can agree on like what kind of packet type or what kind of, you know, data message, whatever we receive. So what I'm actually going to do is I'm just going to copy this for now. We're not actually going to use it. We're going to repurpose it, but I'm still going to copy it just because I want to make sure that we have some code here to compile to test out this common library compiling, right? So I'll leave that in there because again, you can see it's very, very standalone. It doesn't actually use any functionality from Walnut like chat or anything. It's just got these two includes and that's it. So it should be a pretty good like dummy code file. Okay, so this is getting complicated, but I think we have everything we need. So server, we do have a build cube server. So there's a build cube server, but also a server headless. So we don't really need the non-headless version as we've determined. And then if we have a look at this, we'll just make sure, I guess, this is called cubed server. It's a console app. Let's have it read from like the source directory here for all the files. It does include GLFW for some reason. We must not have copied this, I think, from Walnut chat because obviously this is like the non-headless version basically. So if we look at app server and build app server headless, yeah, this looks different. So I think I'm probably going to want to copy all of this and then let's just paste it in. So that will also do the networking stuff that we need. It'll make sure that we're using app common headless, which we renamed to cubed common headless, Walnut headless, Walnut networking, all of that stuff. So that should be a lot better. And obviously we need to make sure. Yeah, I'm sure I've made mistakes throughout this. This is just the reality of like dealing with stuff like this. So we really need to just run this and then obviously see if we can get something building. That's really going to be step one. So I've got this like roughly working, I think. Let's have a look at what Walnut chat has had in terms of its setup script. So it built two versions here. It built the non-headless one and the headless one. What do we have inside our build scripts? Do we have any build scripts? We don't have any build scripts at all. So let's just copy the scripts directory. We'll paste it in here. I'll close this one and we'll edit our one here. So Walnut vent, I think this is fine. But then we'll just do the file that we'll build will be, yeah, I guess build.lua and build headless. So I think I'll just rename this to like build client and build server maybe. So this will be build client and build server. The reason why is because we don't have like a non-headless and headless build. It's just like the server is headless and the client is not. So
build server, it should just, yeah, have cubed common and cubed server headless inside cubed common and cubed server. And that's inside app. Otherwise, it's just this, I guess. And then cubed client will just have cubed common and cubed client. Yeah. I mean, I don't know. I think that that should be a decent start. So let's go into here. What I'm going to do is I'm actually going to open a terminal here just because I want to see, I think it might exit immediately from it when I run it. So I want to see the log messages. So let's run setup. Okay. So we get system cannot find the path specified. So most likely what this is probably, it's a kind of annoying error message because it doesn't give you any context to it. It either means one of two things. Either it can't find Premake, so it can't run Premake, and that's what it means, because I think that's why it says the system cannot find the path specified. Or one of the includes here, it can't find. So one of these directories is wrong. So back at directory, we should have, yeah, build client.lua, and then that's going to include Walnut, build Walnut external, as well as cubed common. So build cubed common.lua. You can see we didn't rename these. So that's probably what it was complaining about. So let's just rename them quickly. So build cubed client instead of build cubed as well. Okay, so now if I go into here, I was in Walnut chats directory earlier, so I had some errors, but now that we are inside cubed, definitely let's try and run setup.bat, and there we go. We generate a whole bunch of project files and solution files and all of that. So we should have cubed client and cubed server. Let's open up that client and see if we can actually get something building and running. Okay, so we've got a bunch of different things here. We've got cubed app and cubed common over here. So we need to rename this to like cubed client. And then we've got Walnut, and then we've got all the dependencies. So this is what our project structure looks like at the moment, which is cool. We might as well just rename stuff immediately. So cubed client has this build cubed client thing, which is called cubed app. So let me just call this cubed client. Getting really tired saying cubed all the time. Let's rerun setup.bat, and now we should be able to reload this, and it should be changed, right, to cubed client. I guess I also want it, you can see it's selected cubed common as a startup project. That's why it's in bold. Whereas I would prefer it to have cubed client as a startup project. Now you can see it's because it is actually set to cubed client, but when we first generated this project, it was set like cubed app was the name of this one. So there was no project called cubed client. And in those cases, like when you regenerate it, unless you actually delete all the files, it won't change that startup project, since it's kind of saved it into like some user profile probably or something with Visual Studio. So that should work going forward, but it just didn't work for us. So let's just set this as a startup project. If we cleaned up all of the Visual Studio project files and started again, it should in fact select it as a startup project. Okay, so let's try and build everything. I'm trying to go as fast as I can through like this sort of phase, just because this is, you know, somewhat kind of boring or boilerplate, but hopefully it is giving you at least some insight into what it takes to get like a project, I guess, building from the ground up. Okay, so we need to compile. So Walnut networking, I think, is upset because we need to compile using UTF-8, just because of the latest version of speedlog, or like whatever version we updated to. So it's coming from here. So yeah, so that's something that I guess I'll have to probably push to Walnut networking. So if we go into Walnut modules, Walnut networking, and then build, I guess, Walnut networking, we just need to make sure that on Windows here, so system Windows, we have build options and then /UTF-8. If we rerun this, I'll just run setup.bat. Let's try to build everything again. Okay, cool. So that seems to have, okay, well, here it is building it now, but we can't open app common lib. So why is it called app common? Something must be still linking to app common. So one thing we can do is actually this whole cubed project. Let's open this folder over here inside VS Code. I like to have, you know, Visual Studio's open to my solution, which is great, but that doesn't include all the files, whereas VS Code will. So I like to also open the directory a lot of the times in VS Code. And therefore, you know, if there's any tools inside VS Code, I can use them across this repository as well, which is nice. But here I'm just going to search for app-common, because that obviously shouldn't exist anywhere. And if it does, then we can change that. So we'll ignore the VCX projects because they're generated. And you can see build cubed client actually does link or tries to link app common, whereas it should link cubed common. So that's hopefully fixed. So now we go into scripts, we rerun setup.bat, we go back to Visual Studio, we reload Control-Shift-B. The life of a programmer. Okay, we're building, finally. So now in cubed app, you know, if we hit F5, like we should be able to actually run something. And here we have Walnut running, but it's inside our repository and it's external and we've set it all up. Fantastic. Now, what I want to do before I go forward is also set up the server. So cubed server, if I open that up, we should have cubed server, which should be headless, right? So let me just try and build all of this as well. You can see we are getting some issues here just because this app wasn't even headless to begin with. So like it tries to use GUI, so those errors are obviously fair enough. We also need to make sure that we are building again with UTF-8. But what's this in? Walnut headless. Okay, so Walnut headless doesn't actually have that UTF-8 thing. So let's open up, so Walnut and build Walnut external headless. So inside Walnut, we'll have build Walnut headless and build Walnut. So build Walnut has UTF-8. This one doesn't, so let's just make sure that we add that build option, and then let's regenerate everything, go back to our server, reload, try and build it. And in the meantime, you know, we can have a look, I think, at Walnut chat, and if we have a look at what the server looks like, app server, then maybe this will just give us some ideas as to what we can do. Well, yeah, if we just don't do a headless thing, then it should still start up. So let's try that. I'm also going to do something critical here. Inside my error list, I'm going to switch from build plus IntelliSense to just build, because IntelliSense, I don't know, maybe this is just a habit left over from when I used to work on huge projects at EA, but IntelliSense is just super annoying. I mean, you can kind of see here that this is so much noise, whereas really, if I switch this to just build only, look, one error, and that's the only error that we actually have. And IntelliSense tries to kind of, it's probably gotten a lot better since it was 10 years ago, for example. I realize that, but it still seems to, it doesn't actually give you errors based on a real compilation. It tries to, I guess, do on-the-fly compilations as it goes and then just throws whatever errors it finds at you. Whereas these build messages are actually from like where it counts. It's from where you actually try and build this file or this entire project. And that's actual real errors from the compiler, not just like IntelliSense trying to partially compile certain code fragments potentially that might not even be real errors, because a lot of the times they're actually not even real. But anyway, so this is the problem. Walnut image, we can't open. UI that wouldn't work. And this is obviously stuff that doesn't exist because, well, we don't have UI, we're headless. So let's just get rid of like everything, I think. Were we pushing a layer on here? Yeah, server layer. And then server layer, I guess, yeah, just had its own kind of stuff. Okay, so let's do this. Let's do, I still want some stuff from here. I think we're gonna most likely end up, well, we'll definitely make a new file for all of this stuff. But for now, let's just have on update. I think we have like a time step here. Yeah, okay, cool. So let's just try out, we'll try out the logging as well. So this should be like Walnut, like a log or something, or core log. So let's do Walnut info, time step, server time step. And then, yeah, we obviously know this applies. We'll call this cubed server. We'll push on that example layer and that's it. Okay, so let's try run this. Okay. We need to add that Unicode support thing again. So if we go to cubed server, we have our build cubed server headless. Let's just add, I don't think I've got it off the clipboard anymore. So build options, and we'll do /UTF-8. All right, setup, reload, Control-Shift-B. Okay, that compiled, let's run it. Okay, so you can see we're running, it says client, but that just means like the client application rather than the core Walnut, but you can see that it's obviously running at a very, very fast time step. So one thing we might actually want to do is slow it down. So let's just do this thread sleep for, and then we'll do like, I don't know, 5 milliseconds or something. We're probably gonna, you know, we'll do this more seriously later, but I just want to establish at least something in the beginning. So we'll do using namespace, std, chrono. Literals, it's usually how I like to do it. That just lets us do like ms, for example, here for milliseconds. And now if I run this again, then you can see it's obviously a lot slower than it used to be, but our server's running, it's running headless. So things are pretty great. Now, I think Walnut headless probably, or is it even in here? Maybe it's not, maybe it's in Walnut chat. But Walnut chat actually includes some sort of headless log, I guess, headless console, right? App server, yeah. So we'll probably steal this as well, just because this lets us, you know, type in messages and like commands into the actual server and then have them printed, but also have like a message callback. So if we need to actually get the server to send some data or kick a player, we can implement it using this headless console inside Walnut chat. So we'll definitely be using that in the future, but for now, I think this is a good start. Okay, awesome. So what we've done might seem pretty simple, but it's a really good start because we have a client application like this, and then we have a server-side headless application. And so really the next step is going to be to get the two to communicate. So the first thing I want to do is I want to
basically, I want to set up this window to be a little bit more like a game. So at the moment, you can see it's set up to be an app, which is cool. We've got this like custom title bar. It looks really nice, but obviously games don't typically look like this. And it's a dock space. So this whole area is a dock space. There's no real area here to render graphics. I want these IMGUI windows to basically act like just floating windows on top of our canvas that we're going to eventually render our game to. We're not going to deal with specific Vulkan rendering and making a Vulkan renderer in this video because that actually would be crazy. This video is crazy enough as it is, I think. But what we can do just for the purposes of this video is at least set it up properly and also use IMGUI's built-in drawing functionality to render things like, you know, circles or rectangles. So the first thing I want to do is inside here where we actually create the Walnut application, I'm just going to do spec.use dockspace false. So that's going to just not use that dock space. And I'm also going to get rid of the menu bar callback because those menu bars only really work if you have like a full screen dock space. Otherwise you have to add it specifically to a window rather than just globally. So this is what we're looking at. Very basic change. Oh, and also I guess custom title bar also set to false because we've gotten rid of the dock space, so we're not going to have that window anymore. So you can see now we've gone back to a plain application. Looks kind of bad compared to what we had, but it will probably look better as a game, right? And then here's the dock space. You can note also that we can drag these windows out, which is super cool. I love that. It means that if we're actually using IMGUI, which we probably will in the future to debug things, we can have it set up somewhat like this. And then that way it's like not interfering with our viewport, which is cool. But if we wanted to, we can also have them over here, and I guess we can dock them even within each other, and then they're part of this window, which is awesome. So if we did want to draw something here, how would we do it? And let's establish this initially, just because I think that's important. And, you know, what we're going to try and do today is we're going to set up that server client communication. But I also really want to not just send, you know, arbitrary text messages back and forth, but I actually want to be able to connect maybe with two clients to the server and have them move around and have some visual representation of both players actually moving around inside this common game world. So I'm going to initially represent these players as rectangles. So what we can do is IMGUI, if we go to just imgui.h, we have like, I think like draw rectangle or fill rectangle, rect, fill, add rect. Yeah, here we go, add rect filled. So you can see I'm really trying to find this stuff. Here it is. So we've got these primitives that we can draw as part of our draw list. And you can see there's add rect filled, you know, add rect filled multicolor. There's a whole bunch of different things. We can draw lines as well, even like, you know, curves and paths, and we can add images, and it's great. Like it's a little rendering API that we could theoretically even use to build a game. But of course, we're going to go a lot deeper and make this 3D and, you know, blah, blah, blah. And we're going to have to actually build like a Vulkan renderer for that. But we'll get there eventually. But for today, let's just see if we can draw some of those primitives. So the first thing we really need to do is, you know, somewhere over here, I guess in on UI render, we need to get like, say, the background draw list. So this gets us an IM draw list, I believe, like this. So we have our draw list, and then from here we can simply be like, hey, I want to add, you know, a filled rectangle at a particular point. So let's just say I'm vec2 50-50, and then we'll give it a max as well. So maybe like 150-150. So this isn't a size, this is just like, you know, min is up here, and then max is this green one over here. So this is that point, and then that is this point that we're specifying. We need a color, so let's just make it like pink, and then we won't worry about rounding. So let's have a look at what that creates for us, because we should see some kind of rectangle. Now, the interesting thing in general with IMGUI is we do see a rectangle, but you can see it's literally at the coordinate 50-50 of our monitor, not local to the window, which is pretty crazy at first glance. So what we need to do instead is offset it by where the window is. So we can do like IMGUI get window position, which is a vec2, and then to that we can add this, for example. And then we can say that IM vec2, this is like our min, and then our max will simply be our min plus this. Now, in order to use plus with IMGUI, you actually have to define that. So, and the way they've done it is a little bit annoying. Maybe there's a better way, but we basically need to find where, I think application GUI will include IMGUI, which is inside Walnut, which is annoying. But basically, somehow before we include IMGUI in either, I mean, I guess we could just add this to our, we could probably add this to our build script, or like to our build configuration, which we probably should do. I think I will do that. But basically what we need to do is we need to define I'mGUI define math operators somehow before including I'mGUI. And so we can do that here. And if we go back, you can see that now works. However, this requires us to modify Walnut. And also we don't really need to use this within Walnut, just within our stuff. So what we could do instead is take this define and just have it be something that we ourselves define somewhere in Cube. Now, if you did actually want it to be across the entire project, you can do that. So what we can do is if we go into like build client, for example, at the workspace level, we can specify a define. So we can be like defines and then just have that specified here. Or we could go into a specific project like cubed client, and then over here, you know, we could have a define just like we do, I think, you know, for Walnut platform Windows. So I might just do it at the workspace level, since I guess this applies to everything. We don't really need it for the server because we don't even use I'mGUI in the server. So I'll just leave it here for the build client.lua script. So let's run setup again. We'll reload this. Make sure that we don't have this inside our application GUI, and we should still, you know, be able to use those math operators and they should compile fine. Okay, so that's just a little note there. So now that we have min and max, let's use min and max. And now that pink square of ours should actually move along with the window and not be tied to the monitor, which is probably not what we want by default. Okay, cool. So there we go. If I move the window, that thing moves. Awesome. So we now actually have a way to draw things. So step one, I think, is I want this to now be a function. So let me come out here and I'm just going to do static void draw rect. We can take in, we could use GLM here. I'm going to keep this simple for now. We'll just take in float X, Y, and width and height. I'm just going to grab this, paste it into here, and then obviously this is going to be our width and height, and this is just going to be an X and Y. And then I guess I'll also take in a color, which I'll write over here. And then we can just call draw rect, you know, we'll do the same thing, 50, 80, 120, 80, and color. Let me just mix this up a bit. I don't know what this will be. This will be kind of pinkish, I think, but just light. Oh, it's great. With a little bit of green in it. Okay, cool. So yeah, there's our rectangle. And now we've got a function, obviously, to do that instead of copying and pasting this code every time. Cool. The beauty of functions, right? All right. So let's move on to some client server stuff, because that's really the goal for today. I think what we'll probably do in the next video is I'm going to talk about that application architecture that I keep mentioning in all my code review videos. And we'll actually set up like a renderer. I mean, renderer we'll probably do later, but we'll set up the actual application architecture, I think, properly for this game. Make sure that that's all working. But we're not going to worry about that today, because I want to focus on the networking aspect and just make sure that we can basically communicate between the client and the server. Now, the first thing I definitely am going to have to do, though, is make a new file, regardless, because otherwise it's going to get very, very messy. So inside the source directory, let me just add a new file. We're going to call this client layer. So this is literally going to be, we'll do client layer.h and client layer.cpp as well. And we should probably make a namespace here called cubed, I think, for all the cube stuff. This is going to be like the root of our application, and it's going to be like a Walnut layer. So layers are just basically like these, I guess, classes that you can ultimately create that will receive like update, render, and events as well. So it's something that you can add to your application, and then inside that application loop, every frame is going to call like the update function, and whenever there's like an event, like a key press, it will also notify you if you want to be notified. So really what it does is it just connects us to that actual core application that we obviously can't really modify because it's inside of Walnut and we're not supposed to. So let's include Walnut/layer, I'm guessing. And if you actually open up this by just hitting F12 on it, you can see what this gives us. So I could just copy all of this and then I can override it, and you can see that this is what I'm able to do with this. So I can render UI using I'mGUI. I can do things inside this update function that's called every frame with a time step. And then on detach and on attach is basically like the initialization and shutdown of this particular layer. So let me include inside the client layer.cpp, I'll include client layer.h. I'll make my cubed namespace, and then I'm going to create method implementations using Visual Assist, but you can see that's basically just automating the creation of this code here. Okay, cool. So this is where I want to do everything, obviously. So back in cubed app, I'm going to just grab my draw rectangle function, put it at the top of this. Again, this is super temporary because we are going to have a proper renderer later. Think of this as kind of like a debug renderer just for us to have here initially. Let's include I'mGUI because we obviously need that. I might grab this little hello button thing we have, or in fact the demo window maybe, just to make sure that we have some UI rendering here. On update, I'm not going to care about, and on attach, I'm not really going to care about either. I'm also going to include Walnut application here, which should give us some more things as well that we need. In fact, if we go to client app, I think, yeah, application really just has most of the stuff in it. So this example layer now really doesn't need to exist because we've replaced it with our actual kind of real client layer. So let's have our client layer. And in fact, what we can do, I think, is push layer probably has, yeah, a templated version of this. So if we wanted this to be a little bit cleaner, we could just do app push layer. And then over here, we can actually put in client layer, and that's it. So we're just pushing layer, client layer. And client layer is obviously going to be our cubed client layer, which we will also, get rid of this, which will also include. All right, cool. Let's try and build that. Okay, so inside client layer, we're getting a really weird error here where it's not happy with these operators, even though we have the define obviously in place. Furthermore, it was working inside here. So I don't really, maybe I do know what's different. I'm not sure exactly what's different about these two files. There were some includes that I removed earlier, but after a quick little search of this actual define and where it enables the operators, it's inside IMGUI internal.h that it actually defines these operators. So you can see that if this define is on, then here are the operator functions that we can use. Therefore, this file obviously needs to be included in some way, but I don't know why it worked before. So if I include IMGUI internal, we're fine, because that's where the operators are defined, or at least declared. Well, actually declared and defined, according to this, right? There's the definition as well. So it's a little bit weird, but if I do that, then I think it will compile. So weird, but that's really like a little tip, I guess, for everyone is, you know, if something weird like that's going on, just hunt down exactly where the thing that is not defined should be defined. And you can see that led to me discovering that it was in fact inside IMGUI internal. So clearly this has to be somewhat included, otherwise you're not going to have access to that regardless of the define.
So anyway, now that we have this draw rectangle function here, let's try and add something a little bit more interesting than this potentially. Let's extend this so that we can move around. So what I want to do is just add, let's just say player position, and we'll include GLM. This is a good test as well because GLM might not be included. So if we have a look at maybe build cubed client, I don't think it is. I said it actually include directory GLM, but are these actually set? So one way that we can check for sure is if we go to the property pages for this, I just clicked on that and press Alt Enter, then we can go into C++ General and then the additional include directories here and just make sure that we do in fact have GLM. But I think this is not really going to be correct. So these I think are right, but you can see these are missing an extra walnut. They need 2 walnuts like these two have. So it's back into a directory, then walnut, then vendor. Actually, maybe not. No, actually I take that back. These are fine. They don't need 2 walnuts because the vendor directory isn't in the walnut directory, but it is in the walnut repository. But this is obviously wrong. So this has to be /walnut and then /vendor/GLM. So where is it getting them from in the first place? Okay, here it is. So build walnut external defines it as /vendor then GLM. So I think generally when walnut is built externally like this, it would be in an external directory. Therefore, it would be like in a subdirectory called walnut. So let's just change that to this. I'm surprised this worked though, didn't it? I don't know. I don't know what's going on. Let's just try and rerun that script and we'll have a look. Okay, well, this seems to not be an error anymore. And if I build the CPP file with Control F7, then it does seem to build. So I guess that worked. So let's just maybe you know, put the player at 50-50, roughly where it was in the beginning. And then inside on update, I'm just going to say if walnut input is key down, we'll have to just include walnut /input/input.h. So is key down, let's just do key code W, for example. Let's do player position. So I guess what we kind of want to do here is calculate some sort of delta. So we'll just say we'll have a direction that we want to go in, and then initially, we'll just use the is key down, I think, to just calculate directions. So W will probably make us go up. So we're going to say that's -1. Let's just copy this a bunch of times. I guess we'll do else if for down so we don't get to do both. They'll override each other, but anyway, this might make it cleaner. So we'll go left with A, we'll go right with D, and I'm guessing down with S. So what we've really done here is we've kind of created like a directional vector. Really, like if this is the origin at 0, 0 over here, this just lets us set our direction to one of kind of 4 points, right? So on the X, it can either be here or here, which is -1 and 1. Ignore the fact that I drew it at y equals 1, but anyway. And then vertically, in blue, it can also be either -1, I'm guessing that's down here, it might be the other way around, and then +1 up here. But we can combine these two, because usually we're allowed to move both horizontally and vertically, and so really what we get here in orange is one of these 4 points. That's if they're both combined to something, and if they're not, then it could just be this, could just be this, could just be this, could just be this, and of course it could just be nothing in the middle as well. And so we basically have like 9 possible directions. Now what you might be seeing here as well is that the distance between these two is actually shorter than the distance between these two, which means that if we do select this as a direction, it's not going to be like a unit sphere in the sense that the distance from the center to the edge is the same whichever direction we go in. It's a square, and so we can actually move, I guess, more. If we just apply that to our position, then we'll be moving faster if we move into these diagonal directions. And that's because the length here is basically going to be like the square root of 2, which is like roughly, 1.41 or something, whereas here the distance is just going to be 1. And so we basically end up moving 40% faster. Now that could be a valid gameplay decision. I kind of like that sometimes. If you move diagonally, you move faster. It's just like one of those things like bunny hopping, that it's just like I was going to say it's like a skill thing that gives you like a learning curve and makes more skilled players perform better at the game. But obviously, moving diagonally does not require much skill. But anyway, so we could keep that in there. If we don't want to though, the simplest way to get rid of it is probably just to normalize that directional vector. So if we just normalize it, then that is going to basically convert it from being a square to being a circle, because it's going to make the length always be 1. And so obviously if you're just horizontally off to -1, so if this is the only key you've pressed is A and you're at -1, that already is a unit vector. It has a length of 1. But if you're up here and it's like -1, -1, that's not a unit vector, and it will bring it down to like 0.707 or whatever it is on both of these axes, and that will obviously make you go that same amount of distance per frame. So there's just a little like small thing to consider if you care. So again, I'm gonna just say optional for gameplay reasons, but we may want to like play around with that, for fun. So now that we have that direction, again, it's not a velocity, it's just a direction of travel. We want to probably maybe convert it into like an actual velocity that we want to move. Now it's common to actually just have this be also a member variable. In fact, I might just make it one. And the reason why is because we might want to like decay the velocity over time. So like add some friction or some physics, basically. This is getting a little bit overkill. Maybe I'm just having a little bit of fun here at this point. But if we do actually make this 3D in the future, which we're planning to, I guess, then we also want to potentially use like a physics engine for that, for things like collision and, well, physics. And so if we're going to do that, then that's going to handle all of this for us, and we're not going to have to do this. So yeah, we'll see. But for now, we'll just, I guess, set the velocity. We'll say that if the direction is not 0, so what's the easiest way to do that? I guess we could just get like the length, and this isn't like, in terms of performance, this is not really a good way. If it's above 0, then we could probably say that we are trying to move somewhere, and therefore let's update the velocity by setting it to, I don't know, let's just have a const float speed. I'll set it to like 5, because I don't know how fast we're going to end up moving, but we could set the player velocity to basically, direction times speed. Otherwise, what we can do is probably have velocity decay by, for example, lerping it down to 0 from wherever it is by some kind of factor, and then if it's small enough, we can just cancel it out entirely, or we could just be like whatever for now and just, I don't know, set it to something like, let's do player velocity glm vec2 0, and then we'll set this to like 0.3 or something. And so this is not really my favorite way to use this lerp function, which I need to probably include something in order to do. Is it even called lerp in GLM? Maybe it's called like mix or something, right? Does that do basically what I want? I think the reason why is because what we're doing is we're basically, so if this is 1, this is 0, it's becoming like a bit of a math class, I guess. But what we're doing is we're basically being like, okay, well, if instead of just like going through from 0 to 1 with some kind of potential curve as well, if we want, we're just saying, let's take 30% of the value every time. So the first time it's going to be here. The next time it's going to be here. The next time it's going to be here. The next time it's going to be here. And you can see that, like, over the course of several frames, it's going to basically get very, very close to that, but not quite reach it. Kind of like this is an asymptote. So I don't like using lerp like that. I feel like it's better to animate it from 0 to 1, but this is just a really quick kind of hack to just add some little physics response, I guess, to this and add some friction essentially, not stop immediately, but have it slow down a little bit over time. Okay, so next up, we need to apply this velocity to the actual direction. And so you can see we're updating it to full blast if a key is pressed, but otherwise we're just letting it decay, basically. Well, we still need to grab player position and then add to it the velocity, but we need to multiply it with our time step. Otherwise, it's going to be dependent on our frame rate and probably very, very fast. So time step, remember, is in seconds. So if this is running at 60 frames per second as an example, I think it won't be. If this is VSync, this monitor is 144 Hertz, so it'll be faster than that. But if it was 60 frames per second, then the time step would be like 0.016 basically, which is a very small number. So that's what we're multiplying player velocity with, which is why that speed is important, because now the speed is not like 5 units or 5 meters, let's just say, per frame. It's basically reduced to 5 meters per second. And so that becomes potentially different, because I guess, yeah, 5 meters per frame would be at 60 FPS 60 times more than obviously 5 meters per second. All right, cool. Anyway, so let's test this out. We're not even drawing the player. So inside on UI render, I'm going to do this inside on UI render just because this is in fact IMGUI. So, maybe after we do the demo window, it doesn't matter. It's drawn to the background list anyway, because we're getting the background draw list. But let's go ahead and just draw this at basically player position. Now remember, we made these if I draw rect, let's make this take in, I'm not going to bother passing these by const reference because they're only 8 bytes. So size, position and size, and then obviously we can just do position.x, position.y, size.x, size.y. So we can pass in player position, and then for the size, I don't remember what we had, let's just say 50 pixels. And then color, let's just make it like, I don't know, pink. Need to pick some nicer colors. Okay, so can't open GLM. I thought we said we could. Oh, well now Walnut can't open it. Oh, great. So Walnut was relying on that as well, even though it was like build external or whatever. That's super annoying. Okay, you know what? Let's make this, I'll get rid of this as well, because I didn't realize Walnut was using this. And then what we'll do is I'll copy this path. What we'll do is I'll just manually put this in to like here. So we're kind of doing this along with, I guess, this stuff up here. Okay, and Vulcanized Decay is an environment variable, so that should be fine. So Control-Shift-B, let's try build everything. Hopefully it will work. I don't know, because this is live, so we will see. Okay, let's run this. It compiled. Okay, I don't actually see anything. So size is 50-50. Position was also like 50-50, right? Did this completely move us somewhere? I mean, velocity should be 0 by default, right? And it should, otherwise it should reach 0. Let's just set player position to like 50-50 just to make sure. May have done something wrong. Okay, yes. So it is drawing it. It's just, it must be wrong. So let's have a look. Maybe I can set a breakpoint and see where it's gone to. Nan. Awesome. Okay, cool. What is this mix function? I'm beginning to suspect the mix function. I mean, this is going to be 0 a lot of the time, right? So if we're going, I guess, between 0 and 0, maybe that's upset at that. I don't think it should be. Okay, I think I know what it is, probably. So length, so direction's already, oh, because we normalized it, but it was 0. Okay, yes. So let's only, whoa, how did I insert a smiley face? That's hilarious. Let's only normalize it if we need to, like this, I think. So that was a bit subtle. Because normalizing requires dividing it by the magnitude, but the magnitude is 0. Okay, that still didn't, that still gives us nans. Awesome. Okay. I'm also kind of sus about this length function. Okay, so that's wrong. Yeah, so that's not the length I was looking for, because you can see it's 0. Is it like magnitude or something? Yeah, length is 2, because there's 2 elements in that vector 2, and there's no magnitude function, right? So what, do I have to use like a GLM length? I think this might be what I want. It's very annoying though. Okay, good, we're not nan. In this video, Cherno learns how to use GLM. So I can kind of move it very, very, very slowly. It might be decaying too quickly. I mean, that's the other thing. If this is running very quickly, then the rate of this decay is going to be also faster. So you might want to maybe do this by the time step and maybe make it a bit higher as well. I don't know if that's what's causing us moving so slowly. Probably not, but we could also just make the speed like 50 and see if that helps. Just common things that might happen from this. Okay, so yeah, there we go. Okay, so now that decay is very slow, so let's maybe make it higher. But again, if you're doing it by time step, this could be anything. It doesn't actually have to be between 0 and 1 anymore. So I still feel the speed's very slow. Oh, well, it's because it's in pixels, obviously. It's not in meters or anything, right? So we are, in fact, moving in pixels. So when I said like 5 meters per second, obviously we haven't really established what that means. So really, it's 5 pixels per second, which you can see is in the scope of this game world. And if we are 50 by 50 pixels, then we're effectively moving 10% of our body width every second. So imagine you're moving like this much every second. Like that's effectively what's happening, right? So if you want to break it down mathematically, that's the issue. So we do have to kind of make it really fast. And you can see that kind of friction and decay now, will happen a lot quicker as well. So if we want it even quicker, we can just make this faster, and then we'll stop a lot faster. But I kind of like that, slightly smoother stopping rather than stopping immediately. Because just to show you, I don't know how well this will communicate over the video, but if we just didn't have this, so basically, what would be the alternative? We're also already throttling it, by the way, so I think we should probably do it here. But anyway, the alternative would just be clearing it immediately, which would mean that we stop instantly like that, which is doesn't feel as good. Cool. So now we have got some nice like damping friction, whatever you want to call it, some decay on our velocity. Awesome. So we got some movement code, and this, the next step is just going to be basically sending that over the network and then having a server that can propagate it to multiple clients. So the next thing I really want to do is be able to connect to the server, to a server. So I think what should happen is inside client layer initially, we can start using some of Walnut's networking API. So we'll do Walnut networking and then client. And so I want to obviously have like an actual Walnut client sitting over here. So I think we can just do, I don't know if we need this to be like a unique pointer or anything, probably not. We can just do client, and then we just need to do client connect to server. This is where obviously like I'd like to have some UI probably so that we can connect to a server. If I was setting this up properly, which is debatable whether or not I want to do it properly for this, I'd probably have like some kind of login screen or like connection be a separate layer, and then that would actually transition into a different layer that is the game once you are connected. Maybe we can talk about that in the application architecture video, but I think for now I'm just gonna make it really simple. So inside on UI render, what I want to do is I just want to first of all access the client's connected state. So let's get the connection status, and then let's check to see what it is. And if it is this inside Walnut or Walnut net? Or like, is this, I'm just trying to see what namespace this is in. Oh, it's in Walnut client. Okay, cool. So Walnut client connection status. If it's connected, then we're basically, playing the game, right? In which case, we can draw our rectangle, I guess, and also process this update stuff. In this case, if the client is not connected, then let's just return because we just got game stuff here. Otherwise, I want to, we can get the connection status. Maybe I should just use namespace Walnut somewhere. So connection status, if it's connected, we'll do that. Otherwise, if it's something else, based on what it is, we can think about what to do. And I might, again, split this up into functions a bit later, but I want to write the code first. So we need to display basically a connect to server box or window. And then this will ultimately just have a input text that's going to be like our server address. We can just use a string for this. I forgot what we need to include. If we want to use the char buffer way, then obviously we need to have like some kind of scratch buffer to actually write these characters into as they get typed into this input text. But there's also, I think, in MISC maybe, CPP, I'm GUI stdlib.h, and then this, which we need to include separately, which is really not letting me drag anywhere. Nice. Anyway, it's in imgui misc cpp. So if we include imgui, maybe it's just in misc cpp, and then stdlib.h, then you can see it lets us do an input text with an actual std string, which is cool, right? So that's what I'm gonna do, and we can have this be, we need this to be persistent anyway, but we'll just say server address. So we'll pop that in there like that, because it wants a pointer, and then text flags or whatever, I don't really care. We'll just have it like be an input text, and then we're just gonna make a button, connect. If button connect, then we're going to do client connect to server, and server address obviously is gonna be that server address that we made there. Now we probably want to resolve it if it's an IP address using like DNS and get the actual IP address. Also like handle the port number correctly, validate it, do all that stuff. But for now, we'll just keep it simple. This is still here from my Windows Explorer. Nice. Anyway, what if I just close that window? No, it's gonna stay forever. Okay, cool, nice. So that's what we'll do, obviously. I think if it's connecting, I'd like to display this stuff, but maybe disable it. And to disable IAM-GUI elements, I'm trying to remember, because you can, in Hazel, we just have like some helper things that can basically pop, you know, or push disabled stuff onto the stack, I guess. So everything under, like in that scope is basically disabled, which is super useful, but I'm not really sure how to do that. I think there's just a flag that goes onto these things, like IAM-GUI text flags, and it might just be, well, it's like read only. Yeah, read only. So bool read only equals, let's just say connection status doesn't equal Walnut client connection status disconnected, right? So if it's not disconnected, then we're probably connecting. I mean, it might be failed to connect though. So yeah, we'll have to, because that obviously is also a state, but we'll display something for that. So let's say that if it's read only, then we'll do, you know, IAM-GUI input text flags read only, otherwise just 0. And I think we can do the same thing for the button. Can we have a read only button? Okay, so there is a push item flag. I wonder if this will also use for that, but there's basically IAM-GUI item flags disabled, which we can push and I guess pop. Yeah, if it's read only. And this is why we usually have systems in place for this in Hazel, just because you can see this gets very messy and also very error prone. So we have like kind of, we use RAI and do some stack stuff that just makes it for the whole scope, for example, which is really useful. So no, maybe this is something that, you know, it would be nice to add to Walnut's IAM-GUI or Walnut's UI API. Now let's get back to trying to connect to the server. So there's a couple different ways we can architect the actual, you know, status of the connection and everything, meaning that like we've got these callbacks that we can set whenever we connect to the server, for example, if we want to be notified by it. We also have a data received callback when we receive data from the server, because this typically runs on a different thread, right? So the client itself will start up a network thread. And then we have this function here called network thread func. So all of this runs on a separate thread. Now, as I mentioned, we are using Walnut networking here, which is completely open source. It uses Valve's game networking sockets library. So you can have a look at all of this. I just didn't want to use Valve's game networking sockets library directly because you can see there's a bunch of code that we would have had to write. I'm trying to keep this manageably sized, right? Not like a full 50-hour course or something. So because of that, I have taken some kind of abstractions and I guess outsourcing some of the work to other libraries like you see here. But I want to stress that all of it obviously is open source. So you can just have a look at all of the code here. Nothing here is like black box or closed source or anything like that. So the flow here is pretty simple. We just try and connect to the server. And then if we do have a connection to the server, then we will receive data, presumably. And we can just handle that data however we like. So what we'll do is inside onAttach, before we even have a connection, we'll just set this data received callback to be something. Now I want to make a specific function for data received. So we'll make a new function here called onDataReceived, right? So this will be data that we're receiving from the server. And then we need to take in, I think it's just a buffer. It might be a const buffer. But anyway, we can look at this set data received callback and it will tell us exactly what that type is. So data received callback is a function of void const buffer, right? So a function that returns void and takes in a const buffer. So if we go back over here, we'll just make this a const buffer. So this will be a Walnut buffer. And then we can implement this function. Now you can see that it's not a static function. I haven't made it static. It's a member function of this because I want it to have access to everything that it might need access to inside this class. So in order to simply like pass it into this set data received callback, it needs to be bound effectively to the current instance of this client layer class. And we can do that by the simplest way to do this nowadays in C++ 20 and a few earlier versions than that as well is by simply using a lambda. That just happens to be you know, more simple, and it also, I think it will result in faster code as well than if you use something like std bind, which you could use in the past. So if we just do, if we just pass in this like this so that we're capturing it inside the lambda, then all we need to do is call that function from here. And obviously the parameter here is going to be that const buffer so that we can basically forward it onto our onDataReceived function like this. So this is typically how I handle situations like these where we need to set a callback, but we want it to call a member function. Okay, so that's great. And obviously this will work. All this does, you can see the source code. All it does is it just sets this mDataReceived callback, right? So obviously if you're not connected to the server, it's not going to do anything. It's just that when the time comes to actually call this function, to call this callback, callback, because we have actually received some data from the server, then of course we can end up calling this on data received function and do whatever we need to. Okay, so let's just try and run this. I just want to see what this UI is looking like that we've written so far. Remember, it should give us, I guess, this sort of box to probably stop showing this GUI demo thing. But you can see it gave us the box for the server address, so we can type in something like localhost, presumably, and a port, and then we can hit connect. And you can see it, in this case, it's giving us an invalid IP address, could not parse localhost, because we should be resolving that name ourselves into an actual IP address. So we'll have a look at how we can do that. But also it's disabled everything. It's not clear that it's actually disabled it. And that's probably because if we put a breakpoint here, the connection status has failed to connect, right? So rather than disabling everything, because that seemed to have been pretty much useless, I thought it would like grayed out or be obvious that it's disabled, but instead it didn't. But anyway, maybe let's just display like a status message below. So if it's read only, I think I'll just get rid of this for now. And then maybe underneath server address, I'll have text, and we can do text colored, and the color we can choose. I think GUI theme might have some colors, right? So we do have some colors here. So there might be some sort of, there's some stuff here from Hazel as well, which is funny, but there might be like an error color. I think invalid prefab is basically an error color. So maybe should really get rid of those prefab related things, because that's obviously a Hazel thing. But we can just have a thing called error, which maps to that color, for example. And that way, I think we can just use Walnut UI colors theme or whatever. That seems like a lot of, that seems like a huge thing to write though. Walnut UI colors theme, error, for example. And then we can, be like fail to connect or something. And this is all dependent on that connection status, right? So if connection status is failed to connect, then we can obviously set it to that. Now we probably have to include this file. So imgui theme.h is located inside Walnut imgui theme. So Walnut imgui theme. Okay, so that actually gives us an int, does it? Color. All right, because it gives us, yeah, just an IMU32, whereas we probably, I guess we want a vec4. Okay, so there seems to be color, which can take this in, I guess. And then obviously it's got an implicit operator here to convert it into a vec4. So we can actually we can wrap this, I'm guessing, in an IM color, and then it should work. So just like that, we can wrap it. Okay, cool. So let's try this. So this will give us a fail to connect. And then, we could also have like an else if connection status is connecting. Then we can also do like a text colored, but we can do basically like a bit of a gray or something. There is a text darker actually. So maybe I'll use text darker and we'll just write connecting. So we're just giving ourselves a little bit of status here, just like some feedback to the user so we can see what the current operation is, because obviously it's not clear. Okay, so now if we type in something like this and hit connect, wow, we get an error. Cool. All right, let's have a look at this. Okay, it's the pop. Yeah, okay. I should have gotten rid of this as well. That wasn't as exciting as I thought it would be. Okay, connect, and then we have failed to connect at least. So we know what's going on. And if it's actually trying to connect to something, which we won't, oh yeah, there we go. Then it will display connecting, and then I'm guessing eventually it will say fail to connect, maybe? It's taking a while. Oh, just disappeared. That's weird. I would have expected it to be fail to connect, but it's actually disconnected. So it remained, I guess, as connecting, and then instead of fail to connect, it just like timed out, I guess, maybe, and went back to disconnected. Very interesting. All right, anyway, so yeah, we've got the ability now to connect to a server from the client. And then once it does actually get set to connected, so I'll just get rid of this. Once this does become connected, we just won't see this anymore, right? So this connect to server only exists if the status isn't connected. Otherwise, we're actually going to display, at the moment, our player rectangle thing. On update will also be running if we are connected, but not if we're not connected. And then when we receive data, that's when we can process it and basically apply it to our player, hopefully. So now that we've done that part of it, I think we can probably open up the server. So in the root of our repository, we have cubed server solution. And then let's basically write a bit of a server here. So I want to create some sort of console, as I mentioned. So Walnut chat inside app server has this headless console situation, right? So I want to have this headless console. Let me just grab maybe this. Okay, so I've just pasted in the headless console files over here, and I can go back to scripts and rerun setup.bat. So we should have them over here now. Hopefully they'll just compile. I don't think they use anything too weird, so let's just hit Control F7 on the CPP file. Yeah, that's fine. So again, you guys can get that from Walnut chat, obviously, as well. This repository will be on GitHub as well, so you can look at that. But if you wanted to get it from the source, then you know where I'm getting it from. Okay, so example layer, same situation. I want to create a server layer, basically. So over here in source, let me create server layer, and this is going to be obviously responsible for running the entire game server. So we're going to have to branch this out, I'm guessing, into something a little bit more complicated in the future, depending on how far we go with this project. But in the beginning, we're going to set up basically the same situation as what we had for the client. So we're going to have a server layer. It's going to be a Walnut layer, which I will include Walnut layer, and then it's going to have, I guess I could just grab these functions over here and let's just do override. And then in the CPP file, let's include server layer and let's do namespace cubed. And then I will implement all of those functions. All right, cool. So I want to create that headless console that we just put in. So let's include that. Let's just have a quick look. So headless console, I think we just need that. So let's just do headless console. I'll call it console. And then that should mean hopefully that we can, do we have to, it's running on its own thread, I think. So I don't even think we need to do anything. I mean, there is a set message send callback. So this is important, obviously, because we want to be able to know whenever a message is sent. So let's do a similar thing that we did just then with the client, where we have a data received callback, but here we'll have it on console message callback, maybe just on console message. And then let me just have a quick look at what that is. So it's string view. So it takes in a string view as a parameter. So that's our message. Let's implement this, and then inside on attach, I'll just do mconsole set message send callback. We'll capture this here. We'll have our std string view, which is our message, and then we'll call on console message with the message. So there we go. So now we can basically do something like process a command if we need to. So we, from here we could do everything. We'd be like, hey, if the message starts with, a slash, for example, then we can be like, okay, this is a command, so let's like process that or whatever. If we wanted to do like /kick or something like that. So that's, that lets us do that, basically, handle those messages that are coming in from that console, because now we've got the ability to basically write stuff through this headless console as well as post messages. So if we wanted to, we could also be like console.add message, or, italic's not going to do anything. The reason why it even has that is because there's a non-headless version that actually can like display different fonts and stuff like that, and like bold messages. But I think with color should maybe work, or maybe not. This just all does see out, so actually it does nothing. I think the color stuff and whatever is just for UI. So I don't know if we want to use this console for actual message logging, or if we just want to use Walnut's like macros, because they will have color and they will also go to files. So yeah, we'll definitely see, but we do need the console so that we can actually write stuff. So, you called the message command. So we'll have a little test here just to make sure we can call these commands. So let's hit F5 on that, maybe, or not. Why is that not working? There we go. Okay, so there's a time step. Okay, that's annoying, yeah, because we're logging the time step. So let's go back here. Oh, we haven't even pushed on our server layer. Okay, so let's do that. So let me get rid of this. We'll still keep our sleep in here, I guess, although we'll have to move this into the server layer, because now we don't actually have the example layer. We're going to not have in a minute. We're going to delete it, right? And instead we'll just push on server layer, but this can be push layer, server layer, like that. And then we just need to make sure that we include server layer, and that should be it, I think. I guess it's a cubed server layer. Whoa. All right, let's run that. Okay, so we should be able to type stuff here, right? Such as /kick, and then you can see it says you called the kick command, right? So all we've done is just set up this little thing here so that we can actually write messages and deal with them. Very, very simple. So let's start the actual real server though, so that we can receive messages. So let's do include Walnut networking server, and then we'll go ahead and set that up over here. So we'll do server Walnut server. And then this is kind of similar to the client in terms of its API. It doesn't start it until we call start, I think, and we have to specify a port. So let's just do, but I think we have to construct it with a port. Is that right? So you can see we have to construct it with a port, but all it does is that. So we could just construct it, like this, I guess, and we're done. 8192 is just a port that I happen to use for some reason. Once that's done, we can start it now. So if we wanted to, and on attach, I guess, we could do server.start. And now the server's running. We could do stop inside detach, but obviously, you know, we need to, in order for the layer to get detached, this function will get called externally if we pop the layer off, the layer stack. So if the application somehow had functionality to do that, which it doesn't at the moment, then it will call stop. But otherwise, you know, maybe we'll call /quit and it will actually stop the server. So yeah, we'll definitely see. And then once that's done, we have some things as well that we need to do. We need to set up these callbacks if we want to know when clients connect or when they don't disconnect. Now, Hazel actually, because I used Walnut networking recently inside Hazel, but I kind of turned it into Hazel networking and I ended up fixing some bugs and adding some features. So I might have to pull that into Walnut networking. But one of the bugs that I noticed we had was that these callbacks basically need to be set, because if they're not set, then you can see they just get called. There's nothing here that checks to see, hey, did you actually even set that? So we basically need to add something like, and I'll probably pull this in, but we need to verify to make sure we actually have that callback set, that it's not like empty, because if it is, then this will crash because we're trying to call it. And then it's the same situation for, I mean, data received is a callback that you'll basically always have, but client connected, client disconnected, you might not even need that. So it's definitely worth like checking to see if that's even set in the first place before you call it. So let me just quickly add that in. Obviously, yeah, I'll end up pulling this in and committing this to Walnut networking, but in case it's not there, then we just need to make sure that we do that. Okay, so now if we want to know when this happens, like when a client connects and stuff, then inside our server layer, let's set up the callbacks. And we can do that before we start the server. So let's do set client connected callback, and then we'll do client disconnected callback, and then we'll also do set data received callback. And so these, I think, let's see what they are. So client connected callback is, so we have this const client info that comes in. For data received, we have the client info, which tells us which client the data's come from, as well as the buffer of data. And then client disconnected, again, just has a client info. So I want to go over here, and we've got this on console message. So let's also have on client connected, which will take in, what was it, const walnut client info, I think. Disconnected has the same thing, and then on data received also has the same thing with a const buffer. Okay, so those three, let's implement them, and then I'm gonna set up my Lambda wrapping situation like we have here. So we can grab this and then const walnut client info, and then I know this line is getting a little bit long because my font's super big as well, but we'll just call on client connected with the client info. And then yeah, we can copy most of this, I think, for these two. We'll just call on client disconnected with client info. And then here, obviously, we'll call on data received with client info and const walnut buffer. All right, so this is what it looks like. Yeah, we could obviously, I don't know, make this a bunch of different lines. This is like really just a wrapper though. I don't really mind having long lines for stuff like this, because this is just calling another function, you know what I mean? It's like forwarding it, it's delegating it. It's not actually doing any real work here. You're just passing everything along. So the code's almost like not that significant. And I think having it on one line just keeps it a little bit less dense looking and less, you know, a bit more tidy. Okay. So, now I'm code reviewing my own code, which is great. So, what's next? I guess we should probably log something. So this is where if we wanted to, we could actually use this console. This is only useful, I think, the reason why you would want to do this instead of just doing stdc out or using the Walnut macros is only really if you have a GUI version of this as well. So if we had both a GUI server and like a headless server, then of course doing it this way meant that we would only have to have our code written once, and it would work for either an actual GUI console widget that we might have in IMGUI, or in this case, it would go straight to cout basically. So, but with this, again, you really don't, I guess you don't need to have that, but you can just do cout directly or whatever else. So I might just do cout client connected. Actually, let's have a quick look at Walnut. I just want to make sure, I don't know if this works or not, because there was some issue with it, right? So I think what I'm going to do is I'm going to try and use the Walnut logging situation, because this will give us colored text. So info, I think, will be green. And also, if we want, we can also do info tag, and then we can tag it with something. So we can say, hey, this is the server. This whole thing is a server though, so I don't really care too much. But if we don't tag it, I think it will say client, which might be a bit misleading. So let me just tag it with server, and then we'll just say client connected ID equals, and then we'll have client info dot ID, and then we'll have to include Walnut log walnut core log.h. Okay, so there we go. We're logging our client connected. Let's also log disconnected. And then on data received, obviously we can do something with that if we want. So now we effectively have the ability to run a server and, I don't know, receive data. So if I try and just hit F5 here, let's have a look at what happens. Okay, so the server is listening on port 8192, which is cool. So now if I open up the client, let me run the client because we should have the ability to connect here. So let's run the client. And then if I just have the server running over here so we can see, let's just do 127.0.0.1, which is localhost, and then colon, and then the port 8192. So this should be basically, if you followed everything, this should be the default address you're connecting to. So let's hit connect. Okay, we got an error here. This might just be a IMGUI thing, but you can see the client did in fact connect, and here's our ID. So that's great. Now, what's the assert from? Oh yes. So this is what I was talking about. We have those callbacks that unfortunately aren't set. So you can see that what's happened here is we're trying to call the server connected callback because we actually managed to connect to the server successfully, but it's not set. So that's why this should be guarded with an if statement. And then finally, if we have a server disconnected callback as well, we'll crash or we'll assert. So that's actually not even called. So lol. Okay, cool. Anyway, let's run that again. So you can see the client disconnected, obviously, because we terminated the application. So let's try that one more time. We've got our server running over here. Let's do 127.0.0.1, and then we'll do 8192, and we'll hit connect. And there we go, right? So here's our thing. We can move around. This obviously doesn't do anything at the moment, but it's just indicative that we have a valid connection to the server. Because if we didn't, I think it would go away. And in fact, if we try and close the server here, and we have a look, this is going to eventually realize that it's lost connection to the server, and it should go back to that login screen or that connection screen. So let's see what happens. Okay, there it is. Took a little while, but you can see we've just gone back to this state now because it's not there. And it will try and connect, but then obviously the server's not running at the moment. So it should just say that it failed to connect, or it will just time out. I don't know. Yeah, it's just timed out. Cool. All right, cool. So that's great. We've got that going now. Now we could theoretically send data between the server and the client. And I think that's where this cubed common is going to come in, because we have this server packet that we stole from Walnut chat. Now we can decide to have various different types of messages that we might send between the server and the client. And this can basically be like a 2-byte header, I guess, in our message that we send that encodes what kind of type it is. So I think it goes without saying, but initially we're going to keep things really simple. We're not going to worry too much about security. We're not going to worry too much about clients doing the wrong thing or trying to connect multiple times or modifying their own binaries and trying to connect whatever else it might be. We're going to keep things rather simple. So I think the first thing we're really going to do is we're going to introduce this concept of a server being able to handle multiple clients, multiple players connecting to it, and the communication of player-related data between both the clients and the server, but also, I guess, between the clients effectively through the server. So what I'm really talking about is we have this server, which is over here, and then of course we can have multiple clients, and they need to be able to connect to the server. And once they've done so, they probably need to download some data from the server, such as, well, this is going to get specifically into the type of game that we're making, which we're going to avoid in this video, but they might download like what map they're on and what the other players are, what the state of the scene or the game world is as well. But initially all we're going to do is probably download a list, I guess, of all the other players that exist on the server, because we need to display their positions in some form over here on the client. And then once this connection has been established, at a certain frequency, we now need to send updates to the server. So we have to be like, basically, what is our position? What are we doing? What is the player, who is this client, trying to do inside this scene, inside this game world? And that obviously has to happen from all of these clients. And then depending on what they do, that might need to also go down into the clients. So in other words, if this client moves, then obviously this client needs to update that client's position. It gets kind of messy, but this is where you need to make sure that you have a good server and client architecture that can handle all of these messages, basically. So the core of the rest of this video, I guess, is going to be just the messaging that happens between these, and we need to facilitate that communication somehow. So the server itself, I believe, is going to have, I think just built into it, I think it might have a list of clients, right? So there's a map of connected clients, which is great because it needs that in order to actually send each client a message, basically, that says, this is the position of one of the players in the world. Now, inside the diagram that I drew, where we have the server and the two clients, the very first thing that I think we need to worry about is the client's ability to identify themselves. So they need to have some kind of ID ID. Now, there's a few different ways that you could do this. For example, you could have the client itself generate some sort of like UUID, basically. They could both do that. Every client could do that. And then tell the server, hey, this is my ID, so please use this now to refer to me. Because at this point, the server's going to have a list of clients. How does it know which one is which? It needs to be aware of this. But another way that we could deal with this is we could actually have the server be the one that actually creates an ID per client. And one of the reasons why I think I might try to do it this way here, somewhat spontaneously, is because we already receive an ID. So whenever a connection happens, there's an on-client connected, we get a client info. And one of those things is a client ID, which is just an HSteam.net connection, which is really just a uint32, right? So it's a 32-bit unsigned integer, and that's some ID. So what we could do is when a client gets connected, we could actually respond to that client by saying something like server send buffer to client. We could send, the client that actually just connected, we could send it a buffer, and that buffer could contain some details such as, hey, you connected to the server successfully, here is your assigned ID. And that ID could just be this ID. That would make it super simple because then we wouldn't really have to maintain any kind of mapping from a game generated UUID and then a connection ID. Now, I don't know if that might, open up some vulnerabilities because this is the direct ID that we have. Obviously, it's just generated it's a random ID, I guess, that's generated every time a client connects. So it's really only present for the lifetime of that particular client. And if I was making a proper game, like I would probably have the game engine itself generate some kind of universally unique identifier, and that's what we would use. So technically, this probably isn't something I would do in the real world, but we're just going to do it here. We're going to try it out, and if it fails or if there's a reason that we decide in the future to change it, it's very easy to change, of course. So let me create a buffer first of all. Now, the server itself is definitely going to have to send a lot of data back and forth, and we don't want to allocate memory every time we need to do something. So what I generally like to do is create some sort of scratch buffer that we can reuse. So let's just do a static buffer. We'll call this scratch buffer. This is going to be a Walnut buffer. I think I might just try using namespace Walnut up here somewhere. I don't know, maybe. Anyway, when we attach, I'm going to allocate. So we'll do Walnut buffer. I think we can just do allocate some kind of size. So I don't know. Let's do, for example, 10 megabytes is probably a lot, but let's just do like 10 megabytes, for example. Okay, that's actually not a static function. So we can just do this. So we've allocated like 10 meg here, which should definitely be enough. So what we can do now is anytime we need to write some data into a buffer, we just use that actual scratch buffer, and the size of it, we can obviously keep that trimmed down to what we want. So it's a little bit like using a span, I guess, inside a vector or whatever. But the benefit here is just that we've pre-allocated a huge block of memory, and we can just reuse that instead of having to allocate, very small allocations every time we want to construct like a buffer. Okay, so once we've got that scratch buffer, we still need to make our own buffer from it. So I'll actually just assign this to scratch buffer like this. And the reason why we have to do that is because this scratch buffer is going to have obviously a very large size of 10 megabytes, but we need to actually send this buffer to a client, and we don't want to send the full 10 megabytes. Most of it's going to be empty. And so what we're doing instead here is we're creating a new buffer, and you can see the buffer's non-owning, right? It's kind of like a span, as I mentioned. And so we can basically have the size be set to something much smaller for this actual buffer kind of object instance, but the memory that we're pointing to is obviously much larger. So we can just use like a portion of it, which is what we're trying to do here. Because all we're trying to do here is probably send like some kind of acknowledgement that we've connected, and then we should use serialization. So maybe like the packet type or whatever should be the fact that, hey, you're connected, and then we need to send you your ID. So this is what we're trying to send. So how do we encode this into a buffer? Well, we're going to use Walnut's serialization library, which is really the same as Hazel's serialization library. So you can see there's something called a buffer stream writer, and there's also a target buffer. And I think, by the way, that this is all proving that we don't actually need to make our own buffer like we did here, because this will handle it for us. So let's create a buffer stream writer instead. We'll have a Walnut buffer stream writer. We'll just call this stream, and we're going to pass in the scratch buffer, because that's going to be our underlying memory. So let's include Walnut serialization, and we'll do buffer stream, I guess. And then I think we can just do stream get buffer or something. What was this? Yeah, stream.getBuffer. And so this is Walnut's serialization library, which again, as I mentioned, is like Hazel's serialization library. So now if we want to write stuff to it, it's super easy. We can just be like, hey, we want to write some data. I actually don't know what function specifically we want to use. So you can see there's a bunch of write raw. Yeah, write raw is probably what I was thinking of. So we can do write raw, and this allows us to pass any raw type. So for example, in this common thing, we had this server packet situation and we had packet type. So I think I'll just reuse this as I mentioned. So sure, we can keep message as a thing. Client connection request. Client connect is 5. I really should just delete most of this and probably start again. But whatever, we'll reuse this for now. So client connect, let's just say, for example, is what we're trying to pass in. So let's do packet type client connect. So we'll just write that in like that. So let's include, we'll see if this is actually, so where is this technically? It's just common source. So we maybe should just be able to do server packet.h, and that should just be there. Cool. So we've written that in. That's like the packet type. And now we obviously want to write the client info.id. So we've said that, okay, the client's connected, and here is your ID basically that you're going to use from now on to refer to yourself. Now, technically speaking, I'm just trying to think about whether or not the client even needs to know what its ID is. I'm not sure whether or not it does, because I mean, it could use that if it receives like a whole bunch of different updates from all these different players. It could use that to make sure that it's not updating, for example, its own position. So it could exclude itself because it would know that, hey, one of those is me. But that depends how we write the server, whether or not the server actually will just send everything to the clients, or it will only send it to the clients that need updates about those positions. I'm not sure. We'll think about it. But anyway, let's just pretend that we're sending it like this for now. And then let's also process some data that we might receive. So how do we do that? So we basically need to create a buffer stream reader instead of a buffer stream writer. That's if we want to decode it and basically deal with it. So we'll say stream and we'll say buffer, and the position will just be 0. So the first thing that we kind of expect to read here, we can just do read raw, is going to be this packet type. So if I just do packet type, now this function I think, yeah, we'll just read it into there. So I think we can just do packet type, and then we could just read raw like that. And then based on the type that we receive, we may want to do something. So if we receive packet type, let's just say client update, which we actually have here already, which is cool. Then we could assume that, okay, well, what is it going to receive from a client? It might be like an update as to its position and velocity, for example. So let's do read raw, and then I'll do glm vec3. So we'll just say this is a position. It's actually a vec2 for now because it's a 2D game. So we'll do vec2 position and velocity, for example. So we'll read the position followed by the velocity, and then let's just log it, for example. So let's just set the tag to server. I don't know if we can just pass in glm things to the logging directly, so unfortunately I'm doing it this way. I just realized, of course, there's no Z, so that's funny. I'm used to making 3D games and working on 3D game engines, not 2D, but anyway. So there's our server basically being like, hey, I've received some data, obviously for the player. That's the position and the velocity. So let's also remove these, otherwise that is going to be not right. And then player side, right? Or rather client side, we just need to send that data. So if we are in fact connected, then we're obviously over here, and we can basically just send the player position and velocity at the end of this if we want to. Now, realistically, this is where usually there would be a lot more architecture to this. So having it just an update, like we probably have one point in the frame where it's kind of like a sync point, and we'd just be like, okay, is it time for us, for example, to even send data to the server? Because we might not want to be doing this at vsync. In fact, we definitely don't want to be doing this at vsync. You might want to do this, say, 30 frames per second, or 60 frames per second, but definitely not 144 frames per second like this might be running at. But again, for now, we're just going to keep things simple. We'll explore these specific details and problems as they arise in the future. So for now, I'll just do client send buffer, and then we obviously need to encode this stuff. So let's grab Walnut serialization. We'll do stream reader and stream writer, and I guess it's going to be buffer stream actually, which should include both of them. So now I can just do buffer stream writer stream, and then we'll create that same scratch buffer, because I definitely don't want to be allocating every single time we need to send this every frame. Instead, it's just much better for us to have a present allocation that we can just send. It is worth pointing out as well that at the moment we're sending so little data that you could just have a little stack allocation. Basically, you could just allocate enough memory on the stack here for whatever you need and then send that. But I'm creating something that could scale, I guess, a little bit bigger than what we're doing at the moment. So let's grab that scratch buffer. We'll just pop it at the beginning here. That's nice. Didn't actually copy anything. So we'll grab the scratch buffer, pop it here. There's that allocation, and we'll put it onto onAttach. All right, so we've got the scratch buffer that we can use for reading and writing. So now let's do stream. We'll do write raw, and of course I'll write in that packet type. So we'll just do packet type client update. And then obviously we need to encode everything we need into here. So let's also include packet type, server packet rather. Okay, so does that work? It's not inside Walnut. So we'll just do write raw, and this will be a glm vec2. Note that you don't really need to explicitly point it out like that. Like it's, if you just do player position, because that is a glm vec2, then it will write it as a glm vec2. I just like doing this because at a glance, just onto the code like this, you can see that it lets you see what type that is. So I know that, for example, I'm reading this, I'm like, okay, that's 8 bytes of data that's being written like that. So for me, it just makes the code a little bit more clear. So I just like that idea. Okay, and then we'll do stream get buffer, and we've effectively sent our position and velocity to the server, which is great. And the server's just gonna log it. All right, now on data received, this is where we're gonna receive our ID if we even want to deal with it. So I guess on data received, we could be like, you know, Walnut stream. Well, we're gonna need this anyway, but we'll do Walnut stream reader, stream buffer. And then this is where we'll get the type as we did before. It's a buffer stream reader. So we'll do stream. This is, again, something I could just copy, I think, from here. So when we receive data, we could read, you know, let's just copy this, read this. And if it's a client update from the server, then this is going to be like, you know, a list of other clients, basically. So we'll deal with them here. And I'm thinking, yeah, we could probably just be like, hey, these are all the players, basically. Like, here is everything. Instead of singling out the one that we send it to, I think that will just be easier. So in that case, I think it would be nice for us to know what our ID is. So let's do client connect. Was that it? Client connect. So at this point, we'll go ahead and we'll write in our ID. So our ID is going to be just a uint32t, client ID, we'll say. I don't think this has its own ID or anything, right? No. Well, it's got connection though. So maybe it already does that. So where does the connection actually come from? Connect by IP address. Oh, maybe it already has it. Maybe I'm just stupid. Maybe we don't need to do that. But one thing I was going to point out before I forget quickly is that you have to realize that this on data received function is very special, in the sense that it's actually running on the client thread. So it's running on a separate thread to our main thread. So be very careful when you're doing stuff like I'm doing somewhat recklessly, just writing in client ID from this thread. Because if you're also writing to it or consuming it potentially from like a different thread, you can run into problems. And we'll definitely be doing some synchronization and like, you know, proper multi-threading code a little bit later on as well. So that's something to take note of, but it looks like we might not even need it. So let me just see, let's just do Walnut, you know, we have connected. So if we print this, we know we've actually received something from the server, right? But otherwise we'll just, yeah, be receiving the list of the other clients. So let's build this and we'll try and run our server now. Okay, so we get failed to write to log file. Well, anyway, let's run the server. Okay, so server is running, and then we'll run our client. Okay, this looks like it failed. Yeah, so we need to set this up, I think. That was an issue we were having with this. So for now, let's just print this. But yeah, I need to come back and actually make sure my include path, I think, is correct for speed log. Oh, it's still, yeah, I think it's because I included it. Where did I include it? Okay, I think we're just going to fix this now because this is going to be very annoying. Let me go back to this. And then if we go into cubed client probably, and we have a look at the Lua here. So you can see we're relying on actually I think we just stripped the log completely. So we need to also make sure, I think, that we're doing speed log. And also it's, if we go into Walnut, and then I think it's build Walnut external, we can see that it's also /include. So just need to make sure that we've got that path properly figured out. And then we can rerun setup. Okay, and now let's give that a compile, and that should build successfully. So that's good. All right, let's run the client. So the server's already running. So we should have this be like the default or something, because I'm getting tired typing this every time. Let's hit connect. So we're in, and you can see the server is in fact getting the position of this. And if I move around here, we're seeing that here, right? Which is pretty cool, because obviously these are two different applications. This is the client and this is the server. So we're able to see that. You can see, by the way, what I was talking about with the alert function, because this is our velocity and it's very, very small. It's like -37, right? But it's as in my E -37. 37, so like 37 zeros below this, but we're still basically setting it. So that's why it's like important to, you know, treat that a little bit better if you care about your velocity not being zero, because it keeps getting added to the position. But yeah, so this is great. Now, the only thing that we need to really change is we need to be able to connect with more than one client, and then in all the clients, we should see the other clients, right? So this is where that's important. Now, unfortunately, we are also printing length 2 everywhere. So I would really like to see if we have connected, if that got printed, and what our actual ID is. So because we are setting the ID from the server over, so let's have a look if we can see what it actually is here. So we'll do stream read raw, and this will be a uint32t, and this is basically going to be that ID. So server ID, server, I guess I'll do ID from server, and this is what we'll read, obviously. And so we have connected, server says our ID is, and then we'll do ID from server, and then we'll just say, we say our ID is, and then we'll do connection or whatever, client dot. See, the thing is, I don't think we actually share that. So mconnection. So this is inside Walnut networking, but I'm going to have to add a function, I think, that's going to be like basically, what was it? What did it say? HSteam net connection. Well, it can just be a uint32t. So get connection ID, we'll say, or maybe just get ID const, and then we'll return mconnection. I just want to compare these two and see if they're the same, because I have a feeling they probably will be. So we'll just do get ID. All right. So, and what are we logging? That stupid length. Yeah, so let's get rid of that. Okay, let's run this. Let's run the server and we'll have a look. Okay, so obviously we'll connect. All right, we're connected. And then what does it say here? Oh, look, they're different. So server says our ID is this, but our ID apparently is this. Now this looks like the max size of a uint. Is it actually? It suspiciously looks like it. Let's relaunch this and see if we have a different ID. Because yeah, that looks wrong, which is a little bit surprising, unless I did something wrong. Oh, no, okay, so it's not. Yeah, so they definitely don't agree. So that's bad, unless I've sent something wrong, which is possible. I might have made a bug, but anyway, this means that we really should probably maintain our own IDs like that. So I'll just do, you know, client ID or something, maybe player ID. And then again, I am just going to assign that variable directly from here, but you know, you can maybe like lock that or have it be atomic or something, but it's not gonna matter because I don't think we're really gonna use this very often outside of this thread. So that's another thing to keep note of. Obviously, it's fine to have variables that are used by other threads as long as they're local to the thread that they're used in. So the problem is when you start accessing, you know, variables from different threads, if they're all locked to one thread, then obviously it doesn't matter that it's not the main thread, just as long as you keep that rule going. Otherwise, if you want to access that variable from different threads, that's where you might need some kind of synchronization basically, or just a very well-defined order of operations. Okay, so the next step is going to be for the server to actually keep track of all of these client positions and velocities that it's receiving. Now, the velocity I think is important because that's where the whole prediction lag compensation comes into this. If we know the player is moving a particular direction, then even if we don't receive data from the player because the packets might get lost or whatever else, if they take too long to get delivered, we can basically predict where they're going to move to. And that might be like a technique that we explore in the future. We might not immediately use it, but that's why I'm setting it up this way to begin with. So the server itself, inside the server layer, we need to think about this. So when we receive data from a player and it's their particular position from a client info, which is obviously that specific player's ID, we now need to store it somewhere. So this is where like I'd probably have some sort of map. I'm not going to make it an unordered map. I'll just make it a regular map to make it a bit easier to debug because the IDs, which are going to be the keys, they're going to be in order. So we're just going to do uint32t, which is the ID, and then we're going to have like, you know, player info, for example, or player data. And player data is just going to be a struct that's going to have that position and velocity. And this is going to be our player, let's just say our player data. And so again, this is where the threading is important because if we want to add something to this player data and then consume it somewhere else, we just have to be aware of that. And I probably wouldn't do it this way. So what I think I will introduce probably in another video is going to be a concurrent queue. So I'll leave a link in the description to a concurrent queue. So this is the one that I think I've used before in the past. I'll have a link to it. It's a concurrent queue for C++. It's very, very fast. It's industrial strength lock-free queue for C++. You don't necessarily have to use a lock-free queue, especially for this, but apparently it's blazingly fast. So knock your socks off. So this is what I think will drop in in the future, there's releases over here that I'm guessing is probably just like a single header file. This is what we should really use, but I'll show you how you can do that's a lock-free queue. Let's do a locked queue. So I can show you how we can lock access to this. So basically what we do is we create a mutex. So this will be like our player data mutex, for example. And what this does is it just lets us obtain this like mutually exclusive lock if we want for this data. So that the idea is that before we use it, we have to first lock it, and it won't let us lock it if someone else has locked it. So we lock it, then we use it, then we unlock it. Use and unlock start with the same letter. Might as well have written lol. So we lock it, then we use it by calling functions. That's why the F is there. And then we unlock it. So that's the order of operations. And so if another thread comes in here and it says, actually, I want to use it, it can't just use it directly. It has to lock it first, but they won't be able to obtain a lock until it's been unlocked by another thread. So by locking stuff down like this, you're basically guaranteeing that only one thread at a time is able to access this data, whether it be reading or writing. So we generally use this with like lock guards or spin locks or whatever else. You can just call .lock directly, I think, on mutex. That's fine. So if we wanted to, we could just do it that way. But the idea is that if we're sure that we want to put data into this, we can basically just be like player data.lock, right? And then we'll have unlock. And again, you can wrap this mutex inside like an RAII lock, which will basically just be like for this scope, it'll just be locked and it'll magically unlock. That really just calls this. So feel free to just call this code as well. So we can do lock and unlock like this, and then we can access that player data if we want to. So as an example, let's just do player data at the ID. So from client info.id, we'll grab that, and then we'll just, so that gives us a player data. So let's do player data at that place over here, and then we'll just do player data dot position equals obviously the position we've received, and then the velocity like this. Now, obviously we could have created something like this up here outside of the lock, and then we wouldn't have had to have these temporary variables. We could read it within the lock as well. I guess reading just really copies from read data will just copy from, just do a mem copy. So honestly, I'm thinking that we don't need this. Let's just move this into here. And then that way we can obviously just do player data dot position. We can go directly into there, and same with velocity. And that might just be better. Otherwise that's just pointless. Okay. And then if you want, you could also, sometimes I put this into a bit of a scope like this, just so you can see the lock and the unlock and the context of that. But that's all you need to do. And that just makes sure that we can't be, reading from that somewhere else on a different thread while we're trying to write to it as well, because that can obviously cause errors if that stuff's happening simultaneously. Now, the only downside to this is that it'll probably be slower than that lock-free queue that we just looked at that I think we'll use in the future. But yeah, it's like really simple, obviously, to do this. And by the way, the lock-free queue, the way that we would do that is instead of actually processing this here potentially and writing into our player data, we might instead create a lambda of a function that will then execute inside that on update function, right? So it's like we're deferring a function call. Instead of doing it here on this thread, we're queuing it up to be done on the main thread later in time. So again, that'll be something we explore in the future. Okay, so the next step then is that we basically want to go through all of the player data and send it to all the players. So let's copy this because we need the lock as well. And inside on update, which at this point will happen every like 5 milliseconds or whatever. Let's, I guess, do this at the end because that seems to make more sense. Let's lock the player mutex again, and then I'm just going to go through it. So we're going to do for, I don't know, like const ID data inside our player data. Totally forgot the syntax for this, forgot to write auto. So const auto, and then we're using like structured bindings here to actually extract the key and the value. Actually, I just realized I don't think we have to do this. So we'll lock the mutex, but then I'm pretty sure we can just use Walnut buffer stream writer, right? We'll use our scratch buffer here, obviously. And then I think we can just do like stream.write map, which I think will just let us, basically take this player data and just write it to the stream. And the reason why we can do that is because, these are just both primitive types, and obviously they contain exactly what we want to send, which is the player ID, whose data this is, and then the data itself. So actually that's, way easier than I thought it would be. That's done. Now we still want to send, we still want to actually write raw for the actual packet type, I guess, that it is. So we'll do packet type. I'll just do client update, whatever. And that's it. And obviously we've locked it because we need to be able to actually copy all the data from this map into this scratch buffer without it being written to simultaneously. So that's why the lock is there. And that's it, I think. Now we can unlock it. and then we can just send it. So because that's now stored inside Scratch buffer inside this stream. So now we can just do server dot send buffer to all clients, and we can just do stream dot get buffer. We can exclude certain clients if we want, but and that might be an optimization where you don't send the player its own data. No, but the thing is we need to do that. See, that's the other thing, right? So you might think that, okay, if we have the server over here and then we have these two clients, then if this, like the server doesn't need to send this client its own position, but the thing is it does, because this client might be for whatever reason out of sync with the server might have a physics simulation, they might not agree, this client might even be hacking, right? So therefore the server has to be the authority. So it has to basically be like, hey client, this is your position, whether you like it or not, this is your position. So I think that's important, and we'll explore how to get that functioning well, I think, in the future as well. All right, so stream get buffer. Okay, so this is where we could create this outside of here. It's just the actual writing of, really the writing of player data is what needs to be in this lock. So generally when we lock things as well, we want to keep that lock as brief as possible. So if we have a lock for a long period of time, then this might be held back. I didn't really explain this, but what happens with lock obviously is that if two different threads try and lock like simultaneously, or if like you're in the middle of this, but then the other thread tries to do lock, then whatever thread tries to do lock, but it can't, it will just simply it'll just wait. So it'll just suspend the thread waiting for that to become unlocked. So that's obviously potentially a waste of potential work. And so we don't want to, slow down our application by doing that. Instead, we can make sure that we're locking for as brief a time period as possible. Okay, so now on the client side, we just need to receive this client update. And then what I'll do here as an example is kind of the same thing. So I'll copy and paste these two things, go over here to the client, player data as well, I'll just grab. And then once we receive this update, we've already read the actual packet type. So we can probably just do read map, and then we'll do the, what was it called? Player data. So we'll just read into player data, making sure that we lock it initially, and then we'll unlock it. And what I want to try and do, I think here, is basically inside update, when we do all of this and we move the player, I want to, let's not do ourselves yet, but let's actually go through. So we'll have to lock this. So another thing is, if you have a lot of processing to do with this map, like let's just say we were going to do something here that took like 5 milliseconds and we didn't want to block the other thread. What we could do is we could simply copy player data into something else so that we aren't locking the resource that might be in use by another thread. So what we could do instead is we could actually just have this player data map copied from player data like that. And that's obviously locked. And now we can unlock it so other threads can access it, and then we can do whatever we want with it. So that's another technique. Probably not necessary in this case, but I think I'll keep it anyway. So let's iterate through this now. So we've got ID and we've got player data. I'll just say data inside player data. So the first thing I want to do is I'm going to say if ID equals our client ID, I think it's player ID, then let's just continue. So we'll skip ourselves. We won't like do that reconciliation of the server's authority on where we're supposed to be or whatever yet. We'll just do that. And instead what we'll do is if we run into player data here, that's obviously a different player, then I'm going to draw it, right? So we are inside on update and not inside on render. So I think that's probably another thing we should do. Let's grab this and actually do it inside on UI render. So this is where we play the game and we draw ourselves. So let's lock this. And over here, what we'll do is we'll just draw data.position. And sure, we'll keep it the same size and I'll make it, I don't know, let's just make it green, which I think will be this. So let's try and run that. I don't know if this will work. Okay, so what happened here? So the server's upset, I think because I need to include GLM. Let's try again. All right, cool. Let's run the server. Okay, so server's listening. Let's connect to it. Here's our first client. Cool. So now let's start another instance. So I'll go back to the cubed client. We'll debug start new instance. So now we've got 2 instances. We'll have to also do 8192 and connect to the server, obviously. Just have the server log up as well. And I'm going to hit connect. And now we've got 2. Check this out. So one of this is us and one of this is not us. Now they should be at the same position. So the fact that they're not is already a little bit weird. But if I move, check this out. Why are they not the same position though? So I'm this one. Is this working? For some reason it's kind of hard to tell. Let me resize this. Yeah, well, it's obviously moving on both sides, right? Why did it spawn me on what looked like the wrong side? Anyway, there you go. So that's clearly working. it looks pretty fast. Like it looks like it's kind of running in real time. Obviously, there's a lot we need to make sure is happening in terms of how often we're actually even sending data and receiving messages and queuing messages that we receive from the server, and there's a billion different things. But you can see that roughly this is in fact working as we would expect. And obviously we are opposite colors, right? So pink is always us here, and then green is always the other player. And if we connected with a third client, which I guess we should try out. So if I go to client and I start another instance over here, then, once I connect, you can see there's now 3. Yeah, and the positions are interesting. I thought we were spawning them all in at 50-50. So why do they look like they're at different positions? Weird. Anyway, yeah, we've now got 3 different clients, and they're all obviously capable of moving, and seems like everything is in fact working. Okay, so now that everything is working locally, the next step is to take this and deploy this onto a server so that we can really do this whole multiplayer networking thing. Now, because servers, VPSs usually run Linux, if this was a more serious, complex project, what I might do is prefer to work locally on like a real Linux machine. So for example, when I was working on Hazel's multiplayer and I wanted like the whole Hazel engine running on Linux, I just fired up my Ubuntu 24 PC that I physically have here in this office. And then I was just able to get it building and working properly locally, and then also over the local network, get that communication working if I needed to. Now that's because Hazel is like a 3D game engine, and obviously trying to get everything building, say on the server, would have been more of a hassle. So what I'm saying is for more complicated or serious projects, I would prefer to just do this locally on a physical Linux computer. However, because this is so simple and it's just a really straightforward project, we haven't introduced any other dependencies even aside from just Walnut, and Walnut I know of course builds on Linux already. It really shouldn't be an issue for us just to use that hosting a VPS that we set up earlier to actually build this entire application we've made, and then obviously run it on that server as well. So what I'm going to do is I'm just going to take really all of what we have here inside Cubed, not the build binaries or the intermediates. I think there's some actually inside the Walnut folder as well. So to be honest, we can just go ahead and delete all of these because they get rebuilt anyway. I'm just going to take all of this and dump this onto that hosting a VPS. Now, my preferred way of dealing with servers in this capacity, I guess, is actually by using Visual Studio Code, which we have been using a little bit for like searching earlier today. So there's this extension called Remote SSH, which I've talked about briefly before. I absolutely love it. I think it's excellent. Get it? Because basically it just lets you remotely connect to a server, list all of the files, inside the server directories, open them, edit them in VS Code, run a new terminal if you want as well to execute whatever commands you want, and you can even download and upload files like over FTP or SFTP. So really like you don't need anything like FileZilla or going through the terminal like externally here. If you just have this Visual Studio extension, literally does everything for you. And of course you can even do stuff like Control-Shift-F to search across all files in a directory on your server. It's basically as if you had opened a local folder in VS Code. All of that functionality is there. I actually don't know if all of the functionality is there, but most of it seems to be. So once we have this extension set up, the first thing you're gonna have to do is add a new SSH host. Now I've already done this step. And in fact, I also have a domain name, which I've pointed to the IP address of the server we've just set up in Hostinger as well. So because of that, I'll just connect to host, and I've called it uswest.studiochannel.com. So this is just like a little subdomain I've made that points to that server. So let's connect to that. It'll open a new VS Code window for us. I'll type in the root password, and just like that, we're in. So it doesn't actually look like anything's happened, but if we go to this folders over here, we can actually open a folder on the remote. So I'm going to go to app/cubed, which is just a directory I've made that's completely empty for this project. So let's hit OK. It'll prompt me again for my password, and that's it. I'm in. So again, doesn't look like much because we don't even have any like files or folders in this directory at all. But let's go ahead and open a terminal here. You can see where I am over here. Let's list, there's nothing in this directory, right? So now we can basically take everything and just upload it to the server. So I'll just do this by literally selecting all of this, which I don't think it's that big. It's like 160 megabytes here. There's probably some stuff we don't need. But anyway, I'll just drag this entirely into here and we'll copy everything. Another way to do this, which is probably a little bit less straightforward, but maybe a little bit more robust potentially, is I could have just committed all of this to the Git repository that we made earlier, and then just used git like on the server here, to pull, that's also completely viable. But this way of doing things might be a little bit more straightforward for the beginners out there. And also I kind of like how easy it is to potentially make changes. So if we realize, oh, we actually need another file or something, we can just obviously drag it in and we don't have to go through the process of committing it then to git a billion times, until we get it right. So this is a little bit more kind of ad hoc, flexible, faster iteration time kind of thing. Anyway, that looks like it's all done. Didn't take very much time at all. So the biggest issue right now, I would say, is that everything here is root. You generally don't want to run any applications on your server really as root. Now, this is not going to be a how to run a server properly tutorial, mostly because I don't know how to do that. I'm not a server administrator. I'm not even a network programmer, right? I'm just a game engine programmer who knows a little bit about networking, as much as he needs to get by. So therefore, if there are any experts in the comment section, feel free to leave a comment being like, oh, you should do it this way instead. However, what I will tell you, especially if you're at a kind of a beginner level, is that the problem with running things as a root on the server is that root has access to do anything on your server. And so the potential issue is that this Walnut thing that we're running, this cubed application that we're running, if that was somehow to be modified, or if that even had a bug in it, it might have some sort of vulnerability that would allow something to happen that we maybe didn't want to happen. And if we're running this application as a super user, as an administrator, as a root, then there is no bounds to the severity of what could occur, really. Like, it could literally wipe our entire server. But if we instead make a user for this application specifically so that it runs the application instead of root, then we can restrict access, for example, to just this directory, which means that it can't go outside of this directory and start manipulating files on our server or whatever else, because it's just locked to this directory. So if we lock it down with some stronger permissions, basically, we're preventing lots of vulnerabilities from even happening, even if they're there. Because the worst thing it could potentially do is maybe modify or delete this directory, as an example. So I've already got a user here. Let me actually maybe make everything bigger. I've already got a user here called Hazel, which I was using for my Genesis server, which is actually also on this server. So what I can do first of all is just change the owner here using chown to be Hazel. And I actually never remember let me just do --help. I never remember the, okay, so it's user first and then the directory. Okay, so it's owner group and then file. So it's the owner first. We'll probably want a -r as well. So anyway, chown -r for it to be recursive, Hazel, and then I guess everything. So I can put an asterisk or a dot. Now, if I do ls-la again, which shows me everything, you can see everything above this. I mean, it also made git ignore for some reason root still, but everything here in this directory is now owned by Hazel, and that should be recursive as well. No idea, to be honest, this is Linux people let me know, but I have no idea why the dot files did not actually make it there. Maybe because they're hidden, and that command I ran didn't run hidden. I mean, they're not hidden here though. Anyway, that shouldn't really matter because we don't need them. So the next thing we can do is actually switch user to Hazel. So now you can see we're not root anymore, we're Hazel. So the plan now is we obviously need to build this whole cubed server of ours, just the server. So to be honest, there was no reason to copy the client, but anyway, we need to build cubed server for Linux. So how do we do that? Well, if you recall, inside our scripts directory, we've actually got a setup.sh. And that, I think, well, at the moment, it goes back a directory, and then it goes walnut vendor bin premake. So it runs premake 5 inside the Linux directory, which we should have there. Uses clang, and it calls build headless.lua. So build headless, we don't even have a file called that. So I think build server is what we're going to want to run. So let's change this to build server. And now hopefully you can see the benefit of using that remote SSH extension within VS Code, because it's just so easy to just work on this as if we're working locally. Now this push ... will just go back a directory temporarily until we pop, which would have been the right thing to do if we run this script from within the scripts directory, because we do need to go back to the root directory. But since I imagine I'll be kind of running it from the root directory usually by just doing scripts/setup, .sh, I don't need this. So let's get rid of that. Now, speaking of trying to run setup.sh, it won't let us do that because it'll say permission denied, because that script, if we actually run maybe this, it'll tell us that it's not executable. So you can see that there is no like X permission or whatever here. I don't know if it should be here as well. One's for the user, one's for the group. Anyway, Linux stuff. The point is that this is not marked as executable. If it was, we would see an X here somewhere. Yeah, probably like here and here. And also it would be a different color. So to first mark it as executable before we can execute it, we need to do chmod +X. You can also use like the number code if you want to only have it affect like a group or a user user or whatever else. And then we'll just do scripts/setup.sh. And now if we run that lsla again, okay, it's not a different color for some reason, but you can see that it now has that executable permission. I wonder why. I wonder if that's just, maybe that's just an ls thing. I used to have colors here. That's so weird. Anyway, whatever. You know what? I think it might be the fact that it's under the Hazel user. Hang on, I want to prove a point here. I think it might be because it's the Hazel user and there might be like some, yeah, so I've got colors here now. So if I do lsla scripts, yeah, there we go. So I think it's just a bash configuration thing. I must not have configured colors, but you can see that if I switch to root and run lsla, then you can see we've got the X permission, obviously. It's actually, yeah, 3 times. And then we've also got the color here as well, and it's in bold. So let's switch back to Hazel. Yeah, and you can see I don't get any colors. So yeah, probably just like a bash configuration thing. Okay, so now I should be able to run setup.sh. Okay, cannot execute, required file not found. Okay, so this is most likely the same situation as what just happened when we tried to run setup.sh, but it wasn't marked as executable. This is trying to run a program called Premake 5, which I'm guessing is not executable. So if we just grab this directory, let's just do an lsla on that, then obviously neither, like this Premake 5 binary is not marked as executable either. So let's do a chmod +x on Premake 5, and then let's now also run setup.sh again. Okay, same issue. I mean, build server.lua should be here. So let's just, first of all, let's just make sure that we can execute this. Okay, so that works fine. So let's get rid of this and let's run the script again. Okay, that doesn't work. Is that really because it's in the wrong directory? No. Okay, I almost forgot what this is, but then I remembered. So basically, the issue with this is that we must have modified this script on Windows or something. But if you look down all the way here, we have CR LF. So this is like a carriage return and a line feed. That's the end of line sequence. For Linux or for Unix, it's supposed to just be LF. So if we just change this file's line ending basically to just be LF instead of, that's a /, a \n instead of a carriage return and a \n. So this is Windows, this is like Unix, then it'll be fine. Otherwise it's thinking that we want to execute something that I guess is a \r, and of course it can't find that. So it's a little bit cryptic, but I've had this before, so I remember what this is. So let's just change this to an LF and then obviously save the file, and then now if we run this, yeah, we should be there. So again, benefit of a live tutorial, I think. If you actually wrote this setup script on Linux, then you probably wouldn't have that issue, but we must have either written or saved it on Windows, or I don't know, maybe Git checked it out that way for us. Not really sure. I think another thing that possibly could have avoided this is if we actually had gone through Git, then a lot of the times on checking out files, Git will actually modify our line endings to suit the platform that we're on. So if we didn't copy and paste like I just did, but we used Git, it may also have not been an issue for us. But hopefully now you know that is a potential issue. So obviously this works now. So if we just undo a bunch of stuff here, so either we bring this back and we'll have to change our line endings again because we hit Control Z. So there we go. This is what we're trying to run. So let's run setup.sh. Unable to write file to make file. Okay, so that's because this directory, that was another issue I should have noticed. The current directory is actually owned by root as well. We need everything to be owned by Hazel. So what I'll do is I can probably just do sudo and then chown -r hazel, and then the directory I'll pick here is the entire app cube directory, not just the asterisk, which is everything within this directory. So let's do that. I bet the Linux geniuses out there saw my issue when I did it the first time. I don't even know what this is. Okay, whatever. Let's just switch to root because it's trying to elevate us, which we might not be able to do. And then I'll just do this. Okay, and we'll switch back to Hazel. So now you can see that this directory is actually owned by us, which is great. And these files also followed suit. Maybe the asterisk somehow doesn't include the dots. I don't know, whatever. That should be fine now. So let's do scripts setup.sh. And then finally, this is working. You can see we've got a bunch of make files now that Premake has generated for us. This is all in the debug configuration. We can actually just go into the make file if we want and change this to say release, if we want to build it as release. We can just keep it as debug for now because we're playing around with this and we probably want the extra debugging, but that's just something you can do because you can see if the configuration is release, then like that's a valid configuration. And so it's dist here as well, but it's going to build debug by default unless we specify something into make when we build it. So now we should build this. So to do that, we'll need make installed. So if you don't have that, you can do first of all apt update and then apt install make, and you'll probably also have to install Clang. And those are probably the only two things you need to make sure you have on the server. I've already got that. If you have a more complex project, you might actually want to have like a build script as well, which will build it, which might run make, and then it might like use 8 cores or 8 threads or whatever. This is simple enough that we can probably just literally type in make and hit enter and it should just work. So let's have a look at this. Using -J with a number such as 4 or 6 or 8 just to make this multi-threaded would have definitely been beneficial, because you can see it's taking longer than I thought it would. But again, I'm just trying to demonstrate the simplicity here. You can literally just hit make and there you go. It's making. Okay, so it's finally building the actual kube server now. This is our executable. So let's see what happens here. I suspect we might have some linking errors because I don't think we've specified any directory for the dependencies of the directly linked files. So we'll see. Okay, so it actually can't even find game networking sockets. Let's have a look quickly at cubed server. So it should have found that one. I was expecting dependencies of that to potentially not be found. If we have a look at the Lua script here, then this is probably what will, under System Linux, actually link it. So the library directories it's specifying is this. I can already see that's wrong because we have Walnut. And then it's not Walnut networking directly, it's Walnut modules. I think that moved probably since that was written. Then you can see it's /Walnut networking and then vendor, bin, and Linux. And this is what we need, game networking sockets. Now this is required by this, but I think when we build it, we can just probably set our LD library path to be this directory as well. So we'll see what happens. First, I'm going to fix this. So this will just be Walnut modules. Now this does mean I have to run that setup script again, obviously. This time I want to make with like 8 or whatever. And this should be faster. I mean, it's already compiled everything. It'll keep that. But anyway, now you can see that we have linking errors, lots of them, but they're all undefined reference to, and you can see from all of this, it's all the protobuf stuff that I was talking about. So that library is here. Now you can install this library through like apt-get or apt-install. The issue is that the version required by this specific binary of game networking sockets is 23, and I actually couldn't find that anywhere. So I just ended up uploading it, and this will be in the actual Git repository for Walnut networking. But I probably should just update the version of game networking sockets, and that might use a newer version of protobuf, which you can just install through a package manager. But anyway, what we can do to fix this is we could either write a setup script or a build script rather that actually did this for us. I think I'll do that in a minute. I'll show you how to do that. But for now, what we can do is we can just do export LD library path. So what this is it's basically setting our path that we can look for dynamic libraries to load, right? And I'm going to set it to this. So I'll copy this directory, copy path, and I'll paste it in here. So you can see here's an absolute path. I don't think it has to be absolute, but here's an absolute path to that Linux directory. So I'm going to hit enter. This is only going to apply to our current console session, to our current terminal window that we have open. And then if I run make again, then you can see it's done successfully. Now, because that's annoying for you guys to probably follow, or anyone really on your team to follow, it's advisable to instead make a build.sh script, for example. I'm going to copy this bin bash thing from it. And then from here, we can just call make with for example, 8 threads. And before that, we can export LD library path to this. Now, obviously this is absolute, so I guess we would just try and do relative, but if it needs an absolute path, what you can do is you can just do real path, which is absolute path, and then that relative path. And then that should kind of convert it to be that. And actually, usually I use backticks for this. I don't know where I got parentheses from. Yeah, and then if you wanted to test to make sure that works, I guess let's open a new terminal, and then if I don't know, if I just do make J8, it probably won't relink, will it? Not unless we go into bin cube server and we just delete it. So if we do make J8 now, you can see we get the linking errors obviously, but if we call scripts, let's do chmod +x scripts build, and then we're gonna run that build script, then you can see it worked, right? So there's that export LD library path, which should work for basically everyone as long as that's your relative directory. Okay, cool. So now we just need to run it, which again, we could have a run script for it, or in this case, I guess we can I probably will make a run script for it, but if you wanted to run it manually, then of course you just go bin, because the path's annoying, cube server, and then cubed server. Okay, and you can see same issue, error while loading shared libraries. So that's exactly why it's nice to have this, because it actually needs to load this. This is actually a dynamic library that it needs to load at runtime. So we kind of need this again for that, right? So because of that, let's copy this build script. I'll just paste it in here. Hopefully it'll make a build copy. We'll call this run. And then inside run, instead of this, we'll just call what we called here. We can use exec as well, which will just kind of sacrifice the parent context of this script if you want. I'd probably do that. But the important thing is we're also setting that dynamic library location. So now, again, chmod +x scripts run. And now finally, I think we should be able to run our server. server listening on port. Awesome. And I think we've got like, just to see it works. Yep, it works. I mean, that command doesn't do anything, but it does print that message. So that does seem to be up and running. Awesome. So now let's go back to our client and let's try and connect to this server. So there's a couple ways to do that. I mean, this server is going to have an IP address, which I need to figure out. So one way we can do that is just by looking at hosting as dashboard. So you can see here's our IP address. So we can just copy that. So let's grab that. And that's what we're going to try and connect to. So I want to start an instance of my client. The server is obviously still running over here. Let me just make this a bit bigger because we care about this. Okay. So I'm going to paste in that IP address, 8192. I'm going to hit connect. And there we go. So our server's saying client connected. And you can see here we are. So that's great. So now let's start another instance of our client just so we can actually see if it's working. Okay, so here's our running client. Here is our new instance, and we can also see the server log here. Let's paste that in again, 8192, hit connect. And now you can see, there they are. We're both connected. We can move around and there you go. Now, obviously there's a bit of latency now because I think this server, well, if we want to test the latency, I guess we can just go to our terminal and do ping and then that IP address. And you can see the latency is about 174 milliseconds. So that's a decent amount, especially because what's happening is we've got client 1 here that's connecting to the server, which is taking like 174. Actually, is that? I mean, that's a reply. So that is a round trip, isn't it? Yeah, so approximate round trip times in milliseconds. So going there and then getting a reply is taking 174 milliseconds. So that's what our latency is, which is not the best, which is where some like lag compensation and other algorithms could definitely help. But without any of them, you can see roughly what it's like. And that's why it's also so important for the server to do any kind of authoritative things. Like, for example, if these two cubes could kill each other, which might be what's coming next, then obviously, yeah, you'd want the server to handle all these things to keep it more or less fair. But it's also going to depend on the ping that clients can have, because obviously we can play this game globally now because it's running on a server. So that means that what if someone has 30 milliseconds of ping and someone has 250, then it might not be fair, which is where the whole lag compensation thing comes in. Like maybe there should be some kind of compensation going on for larger ping numbers to make it a little bit more fair. Honestly, I remember when like Call of Duty Modern Warfare 3 introduced that and everyone hated it. Anyway, we might explore that later, but you can see now hopefully that this is all running pretty awesomely. Now, one thing I do not like, which I'm going to quickly fix, is that we had to actually type in the IP address of the server rather than the domain name. And the reason why, I think, so if I go to Cubed Client, let's run this again. I think if I try and do uswest.studiocherno.com and then 8192, let's hit connect. Yes, that's not going to work because it couldn't even parse the IP address. Now, this was something that we basically fixed for Hazel. So this is Hazel's repository on GitHub, which you guys can get access to if you go to patreon.com/thecherno and you help support the development of Hazel. So inside here, we obviously have been working on multiplayer. So inside Hazelnet, I think, which is very similar to Walnut networking, we probably maybe even inside platform, I think, for both Linux and Windows, we've introduced this little has port thing, and this is specifically to resolve domain name. So I don't think we actually have this inside here. I will push this to Walnut networking before this video probably goes up, but inside Walnut networking, in networking utils, or rather this is in platform Windows networking utils, you can see we don't have that check there. And that check basically just checks to see if there is a port, and if so, it separates it out. And that's just so that we can not really worry about providing a domain name with a port. Instead, the purpose of this function is we can give it an actual like name, like a domain name, like uswest.studiocherno.com :8192. And if we do have the presence of that port inside that domain name, it will return it back to us, you can see, with a port, which is great. So I'm just gonna grab this whole thing. I'm not gonna try and, in fact, let's just replace the whole file. Although that's a bit annoying because this is Hazelnet utils. So maybe I won't. I'll just grab this function. I just don't want to do like too much of a surgical replacement in case I miss something. So let's grab this, and then I think we're gonna have to include vector. Oh, and then the split string util thing, it exists in Walnut as well, so I think we just need to make sure we use Walnuts. We're already in here actually, so split string, let's have a look. That's in string utils, and string utils is in Walnut utils string utils, so I think we'll just have to include Walnut utils string utils, and that should be pretty good. So that's step one. And then the other thing that we obviously need to do is inside the client when we try to connect. So the way that we're doing that at the moment, I think, is over here in our little connect to server, we're just doing doing client.connect to server directly. Whereas inside client.cpp, inside Hazel's networking, what we have here is this little block of code, which I think is new. And this is different to how Walnut networking does it. So it's this: utils is valid IP address. And if it is, then sure, we can just use that. Otherwise, we're actually going to resolve the domain name into an IP address. And so we actually end up keeping two different things here. We have a server address and we have a server IP address. And the server, they might be the same if you just give it an IP address, but if you give it a domain name, then it will basically keep both, but it will resolve the IP address and use that for actual connections, which is pretty cool. So let's just grab this block over here, and then inside client.cpp, when we try and do that connection, which is over here, before we use the server address, let's paste in this block here. And along with server address, I'll also have server IP address, which we will assign over here. And that's what we'll use basically going forward, because you can see it will get assigned over here. And then utils is valid IP address. I think we've got this function here. Let me just search for it. So it's in Walnut utils is valid IP address. So it's in networking utils, which we might just not have included. So let's do include Walnut networking utils. Okay, cool. Now, when we assign it in the first place, I think inside the connect to server function, we just need to make sure that, yeah, so we end up setting server address, which is the only thing we have. And then when we actually do the connection on the network thread, that's where it will set server IP address to either directly the server address if it's already an IP address, or it will try and resolve it if it's not. Now, the only issue here is that the port might not get separated, but I don't think that matters. I think it's fine because when we pass it into this, it also has the port. So anyway, I think that should now work. So let's run this. I think the server should still be running. So you can see we've obviously disconnected, but the server is still up. So when we run this now, I should be able to do us-west.studiocherno.com 8192, hit connect. And there we go, we're in. Now, we didn't delete the other two players from the server. That's why they're here and we received their information, but they're dead because they're disconnected. And of course, I can open another instance and connect as well. And there you go. Pretty cool. So now we have a multiplayer game example where we have a dedicated server running on an actual like Linux VPS on the internet, and then multiple clients, really as many clients as we want, connecting to that server, and the data is being shared between the clients and the server. So hopefully this was a good example to get you started potentially on working on a multiplayer game over the holiday break. The plans, as I mentioned in the beginning, for this series of live tutorials is pretty ambitious, even though I am trying to keep the scope kind of small. So please let me know what you thought of this kind of video. I don't generally make videos like this on this channel, usually because they just don't seem to do well on YouTube. You know, YouTube's all about the kind of shorter videos that are a little bit more clickbaity, a little bit more like, hey, check this out, rather than like almost like a course, really, which is what this is. So please do let me know if you liked this and if you want to see more of these kinds of videos, because the next step here, there's a few different ways we could go. I think the next step is going to be probably to move away from the IMGUI rendering specifically for all this stuff and see if we can actually render this through Vulkan. So this is almost going to become like a little bit of a Vulkan tutorial, because I'm going to have to, you know, like write some shaders, create like a Vulkan graphics pipeline and render some geometry using Vulkan. So let me know if you want to see that in the comment section below. And then once we have like a rasterized Vulkan pipeline, we probably want to introduce like a ray traced Vulkan pipeline, which is where like the ray tracing 3D side of this cubed game is going to come into play. And then we've already got that multiplayer infrastructure in place. So we'll just have to iterate on that and obviously make it work as like an actual game. So yeah, if you're interested in seeing more of this project and you like the live tutorial programming everything on video kind of approach, then please do let me know in the comment section below. I hope you enjoy your holiday season. Merry Christmas, Happy New Year. I'll see you guys next time. Goodbye.